Okay, so of course the main keynote gets obsessed over by a big team of professionals for weeks, but here I get to be a lot rougher and more opinionated and even a little bit critical. I actually wrote up all of my notes on the plane flight over here, which I know drives a lot of production people crazy, but I think that's part of the charm of this. So here we are 4 years on. And I get reminded of this quite a bit when I started at Oculus as a new employee. I did what a good new employee does, and I adopted the company coding style, which was Michael Antonov's, which included headers at the tops of files with creator and date. So now I still run by all of this stuff and see author John Carmack created 4 years ago. Boy, it's been a long time that we've been working on this. And VR hasn't taken over the world yet, but it is showing up in a lot of surprising places. Just last week, I was at the grocery store, and I looked over, and there was a Gear VR on a poster for some immersive wine tasting experience or something, which is a very strange thing that 4 years ago, we probably would not have predicted that we'd be seeing it in those sorts of circumstances. But there still is this sense that maybe this year we are out of the heroic age of VR, about shipping consumer commercial VR out to people, where the people that signed up for this bold new journey to go out and build these products that that hadn't been out before. And some people expected it to be magic right off the bat, that it would go out and there would be a bolt of lightning, and there would be this huge amount of success. But the truth is, we're a product competing against hundreds of other very good products and very finely tuned products. And it's going to take a whole lot of work to kind of reach that level of success. But I do think I'm optimistic in so many ways. And much of what makes me optimistic about VR now is that it actually feels like all of the pieces, all of the ingredients that we need are already really here. They're just not stirred, cooked, and seasoned exactly how they need to be. When we look at the fact that we have over 2,000 applications in our store, and there's a broad range of quality, but there are some very good things that almost anybody should be able to find something good and interesting in the store. And I look at and say, Facebook is largely an advertising company. We should be good at connecting people with the content that they're going to enjoy, but that's something that we're not doing a great job at yet. But I think that there's huge room for us to improve that, and there's a lot more that we can do. And the fact that 360 media has probably exploded beyond anything I would have expected 4 years ago. A lot of Facebook having 360 in the feed, both photos and videos, is huge. The fact that we have thousands and thousands of high production quality 360 videos and millions of 360 photos. 360 photos are by far the most popular form of user-generated content for virtual reality or for immersive media. And terminology-wise, I have tried to settle on using immersive media more often, because we can have this whole mess of different content types, whether it's 360 or 180 or stereo, whether it's got 60 frames per second or narrower fields of view. And I lump all of this together and just try to say, immersive media, something that's better than looking at media on a flat screen. And I think that there's enormous value that's already there that we're, again, just doing a poor job of exposing to people. The fact that I make this comment a lot. If you look into Oculus Video and you say, I want to watch 360 videos, you could be forgiven for thinking that there are only 80 videos as you page through sort of the top featured things, not that there are thousands and thousands of them available, just kind of waiting to be discovered. So these are some of the things that that Oculus should be doing a better job at. And in our partners, we do have some world-class brands like Netflix and Minecraft that everybody in the world knows that are on our platform. And the web experience that we're providing is getting pretty good. And in many ways, the web is the backstop for all of the apps that you don't have, where there's a web page or an application for practically anything that you could want to do. So again, it feels like the pieces are there. And in many ways, Samsung has done a better job at being user-focused than I feel Oculus has in many ways. When their applications first launched, the original Samsung VR, or Milk VR as it was at the time, or the Samsung browser, I was fairly critical of the initial applications. I would look at them and say, they should be doing this in a time warp layer, this should be filtered better, this wrong option is on here. But they released version after version, and we look over sometime, number of versions of later, and Samsung had the #1 application in VR for a while. And I used that to berate a bunch of people in Oculus about, like, we need to step up our game. Samsung is out there listening to users, doing what they want, providing the features that they actually find valuable. While I think Oculus has, in many cases, focused on, we want to build the platform, we want to build the infrastructure for some of these things, but it's easy to kind of fall into a trap there and not judge yourself on value and impact to the users when you're saying, well, I'm building infrastructure that's going to rely on somebody else to extract this value here. So I do push Oculus very much to try and say, well, let's actually do things for our users, not necessarily for our platform. Often I'm like, in the voice of Tron, we should fight for the users. But many of our applications in the store, we've got 2,000 plus applications, but so many of them are stuck on sort of that first version, like the original Samsung applications, and they don't really get to the point of being able to be iterated on and cleaned up and brought to that level of value. And in fact, some developers go through a series of applications. They build a VR application, do something interesting, then they build another VR application and do something interesting, but they're all only taken to that first maybe 80%. Or sometimes, like in game development, you talk about how the second 90% is always the hardest. And not many of our applications are going that extra mile where all the really important magic and user value happens. And there's a school of thought where that could be the intelligent direction, where if you believe that you need a killer app, that it's something nobody's ever seen before, then it can be completely rational to be sort of point sampling the application space, trying lots of different things or throwing things at the wall and seeing what sticks. So if your thought is that nothing that anybody's doing is even on the right path to being the winning solution, then you just try shooting around randomly in different places. But I'd like to present an alternate viewpoint there, where there are a whole lot of nonlinear value thresholds, where it's not a matter of adding a little bit more work here always results in a little bit more user value. Sometimes there are very nonlinear or very sharp cutoff points where if you look at many of the things about winning and succeeding in lots of different areas, I mean, even the revenue streams at our stores, it hurts to look at these sometimes where you have a handful of applications that go make $1 million here and are very successful, and then you have hundreds of applications where you've had developers put developer years of effort into something and wind up with $500 of revenue from it. And that's really sad, but it's unfortunately, that's reality in almost all of these consumer-facing industries, where sometimes the difference between something that does almost nothing and something that is really huge are relatively minor things. And things like Facebook and Instagram are examples where they had competitors. They had competitors that were doing very similar things. And in many cases, the differences between what became the multi-billion-dollar juggernauts and the companies that went out of business were doing dozens of small things somewhat better. So I would like to push everyone towards trying to work harder on existing applications. And there's another argument for that in that because each new generation of Samsung devices especially, we bring in huge new tranches of users. And that's an opportunity that an older application, cleaned up, improved, has an opportunity to make brand new, fresh impressions on people. And I'd also say that, again, in terms of application discovery and presentation to users, we're not doing the best possible job where an application could go out, vanish without a trace beneath the surface, not necessarily because it maybe didn't have a kernel of something right in it, but because it never got exposed to the users right. It needs the different guerrilla marketing tactics, and all the things that people do to be successful on other platforms also have to be applied to the platforms in VR. And so if you have a brilliant idea, if you think you've got that lightning in a bottle, the killer app, by all means, go ahead and work on it. But otherwise, you can always spend time improving the existing applications. And those are good muscles to exercise. So even if it turns out that that wasn't the magic app, going through the disciplined work of making it as good as it can possibly be is what's going to need to be applied when you eventually do get the magical application. And when I complain, kind of bemoan internally about how much better our VR applications could be, about the things that they could be doing better, why the graphics should be better, why the responsiveness should be better, why the load time should be better, I have people that that could know and agree, but they'll say, but all the devs, they don't have your experience. To which I'd reply, well, go get it. Grow stronger. I'll help. There's a lot of people that do have this experience. You can find old timers that know how to do this type of optimization, and even the new people that know how to do this type of user testing or even marketing. These are skills that that are going to be necessary for success. And some people would like to think that this type of disciplined coding and design within very tight constraints, that maybe if, like in the old days, you could just wait a few years and your lazy design whatever just works on the new computers. That was the way of PC development for a very long time. But we're in a situation now with mobile being important and with the end of Moore's Law kind of drawing nigh, that those types of skills are absolutely going to remain important for the foreseeable future. This future device that we all imagine, where we have AR sunglasses that billions of people are wearing, that's probably going to have at least as tight of a power budget and design constraints as you have on Gear VR. And it's going to have lighter weight, smaller battery, less thermal mass. It'll be expected to run for 20 hours instead of 3 or 4. You are not going to have some magical thing that comes in between now and then that's going to just solve all of our problems. And this distinction between, I raised the hypothetical question to a lot of people. If you had a choice between getting magic hardware and magic software, which would you choose? If I could say, well, I could take Gear VR or our standalones and automatically give it 4K displays, give it twice the power and performance that it's got right now, magical optics that are perfectly crisp across everything, or you could get software that actually does things to the limits of what the hardware we have today can do. And I have always taken the side that right now I would rather have magic software over magic hardware. I think that we have enough extra value that we can put into the software on the platforms we have today to make those kind of critical differences. And I think we could take what would be thousands of dollars of hardware, magically put it down to this low level, and the current software that we have still wouldn't be incredibly awesomely engaging just because some of the hardware magically got a lot better. So I gave a commencement speech earlier this year, and the advice that I gave to the young, impressionable minds there is basically the same advice that I'd give to the older, but hopefully still impressionable minds here. And that's to embrace the grind. Work that you've all shown that you're bold in starting to work on an emerging platform that's not really mainstream yet. But it takes more than just be bold. You have to actually work really hard. And you've got to fill your products with give a damn, to really care about every aspect of them and turn them into the things that you believe in everything, you think you've done the best possible work, because the whole world's first impression of VR is largely ahead of them, and you might be providing it. So every little detail counts. I like to say that success isn't about that one brilliant idea. It's about the doing 500 or 1,000 little things right and getting it all done. So despite my comments about favoring magic software over magic hardware, it's fair to say that the big announcement, a lot of the buzz from yesterday, is around our standalone hardware. And a lot of people have been surprised that I've been the champion of mobile and basically lower-end VR, given my prior history with high-end PC and pushing the limits on expensive GPUs and so on. But I do think that I signed up for this mission of getting 1 billion people in VR, and that's not going to happen with very expensive hardware. And I'm also not willing to just say, well, let's wait 10 years or 15 years so that the capabilities of the very expensive hardware are now somehow trickled down, if that ever happens. I do make the point that you should believe today that literally the power of the PC will never get to a mobile platform. We'll run out of Moore's Law first. It's just not going to get there. We'll get another order of magnitude faster, but we are unlikely to get 2. So if we want to get to this massive scale, it does mean adopting these lower power, lower end mobile technologies. And I like Go a lot. I've been using it normally I spend most of my time actually programming, but in recent weeks I've been spending a lot of my time being probably most valuable beta tester or dog fooder on Go. And I've been trying to take it to the places in my life where I would normally use my iPad. Instead, I'm carrying around my Go, in a little bag for secrecy reasons up until now. Now I can start actually carrying it openly. But this is the place where I feel standalone will fill. It's not your phone, it's not your work computer, but it's the place that a tablet could fill. And I would take it around, I would use it in my, I do my morning trawl of Twitter and Hacker News inside the browser in Oculus, inside the Go. I'd watch Netflix with it, I'd watch movies in it. And in fact, one day, as an example of the different use cases, I basically left it in Netflix, and it sort of functioned as a Netflix machine. The headset was sitting there. I could put it on, watch for 15 minutes, take it off, go do something else. A few hours later, put it back on, watch a little bit more. And that's a very different user experience than working with Gear VR. It's the same software there, but instead of going through the trouble of starting it up, docking it, launching an application, getting through that, friction matters a lot. And I preach this in all sorts of application areas where 1 click versus 2 clicks versus 3 clicks make enormous differences. And people that are hyper analytic about things like website conversion rates and things know the value of a lot of these things, about how long it takes you, how many actions it takes you. And the standalone that can sit there as a device that really is just ready when you put it on, that is a significant change in the experience, even if you do basically the same things. So I'm pretty bullish about the possibilities there. One of the things in me trying to, again, treat this like I would one of the other devices, I left it on my nightstand, and in the morning I'm like, okay, pre-dawn time, let's put on the headset. And of course I was like, too bright, blinding in the morning. So that's when you can think about, well, should we have something like an automatic proximity or sensor for ambient light so you could adjust for that kind of condition? But it's interesting that it does show up some of the trades that were made with Go, where because it's an LCD screen, even when the screen went completely to black on my dark adjusted eyes, it was like, this is still pretty bright. And there's several points about Go where they are net wins, but not pure wins, where there are some trade-offs that were involved. And of course, the biggest trade-offs were, I think the price point is magically important. When I talk about nonlinear thresholds, getting to $199, I think is incredibly important. There's a lot of data from things like console sales, where maybe you start at $400 and you sell this much and you drop to $300, but dropping to $199 is one of those threshold points where you do a whole lot better at that number. And it's also a number that psychologically for a lot of the well-off people, it's at the point where it's a giftable price point also, where, lots of us in VR do not want to buy a gamer PC for our parents or aunts or uncles or something, or if they're not using a Samsung phone, we don't want to set up a whole separate phone for them to set up a Gear VR. But when you've got the standalone that it's just, here's this box, you don't need anything else, open it up, get through it, and you'll be in VR, and you can look at these applications, I think that's really important. But some of the trades that happened, obviously the LCD screen versus an OLED is a big one, where we've spent years talking about all the virtues of OLED displays. Rift is OLED, Gear VR is OLED. And there's some powerful value to OLED. The fact that you get perfect blacks and you get very pure colors, you have very quick response times to it. And these are things that are valuable for VR. But it's worth noting that there are some significant trade-offs to OLED as well. The Rift in particular spends a decent amount of computational time doing mirror correction to correct for the inconsistencies across the individual OLED pixels. And to do that involves generally adding some values to some things which can detract from the pure black argument. And on the Samsung Gear VR in particular, for years I've struggled with the problems with the deep blacks. Anybody that watches movies in the theater or in Netflix, when scenes go very dark, they just don't look that good. And it took me, I only just this year figured out the last piece of that puzzle for why some of those things are. For a long time, we've had the obvious case of there's the two-frame rise ghosting problem. If you have a very dark line next to a bright area, you move back and forth, you will see one distinct frame of a slightly dimmed ghost version. And that happens with the very dark values not able to rise completely to the very brightest values. Again, on PC, where we have lots of performance, Rift does a software overdrive to try to deal with that. It can't handle everything for full black to white transitions, but if you're going black to gray for the next frame, it can boost the gray up a little bit higher and does a pretty good job of working that out. But again, it takes processing power. The other problem is what I've called the black smear problem, where if you have some very dark imagery there and you move side to side, it has more persistence and smears across the screen. And I spent at least 3 times I tried to fix this problem in Oculus Video by adding dithering into, I would put it directly into the time warp layer, reading the movie file directly and the scene file, or the scene images, and I'd add noise, I'd add temporal and spatial dithering, and it never really worked right. And I was very disappointed with this, and I never quite understood until just this year. I was doing some comparisons of the video screens and trying to, again, get to the bottom of some of these problems. So I went into a completely dark broom closet, all the light blocked out, and I had my Samsung phone down there with a color pattern grid in low persistence mode, going from 0 to 255. Stare at it until I could carefully look at everything, and then it was clear that many of the low-order values, instead of being a smoothly increasing color gamma ramp, there are flat spots into it. So there are several areas where it's like 0, 0, 0, and then it bumps up to some non-zero value. And this is why when I'm trying to dither, going plus or minus 1 value there, none of that wound up helping because it was all inside this flat spot. So that's something that I think Samsung could probably fix. I suspect that the way that comes about is you run the proper sRGB gamma curve and say the colors need to come down to here, and you've got different responses for red, green, and blue. So it's mathematically the closest, but what I would argue for is that we should have an always increasing color ramp, even if it meant that the colors weren't as pure and you maybe had hue shifts down at the bottom level. So I think that that's potentially fixable. But in contrast, on the Oculus Go screen, it's an LCD, but all 256 color values are discrete there. I can look at that in my dark broom closet and see that each of these does have an improvement. So the dark black areas that did tend to look actually bad on the OLED screens look better here. It has more subpixels, where something else that's kind of an open secret is that the pentile arrangement that a lot of OLED displays especially use is basically a cheat on resolution. Instead of having red, green, and blue for every pixel in a 2560 by 1440 display, you'll have 1 green for every pixel, but only 1 red and blue for every other pixel. And in fact, there are pentile schemes from some other manufacturers that have even less subpixels, where you have 2 subpixels out of 3 on Samsung. There are some that only have 1.5 out of 3. So this is a difference where the Go screen is full RGB stripes. So it's got 3 subpixels. So there's more actual resolution there. It fills out the space better, so the screen door effect is reduced. You wind up getting some wins there. So overall, I'd say on net, the screen is a positive. A little more resolution, a little less screen door effect, no deep black problems, but it does have the lower contrast that you'd expect out of an LCD. You notice it especially when the entire theater dims down to that dark area. You can still see this kind of gray backlight area, like you're looking at an LCD TV in a dark room. But still, I call it a net win. The other disadvantage of the LCD is that it does hurt latency a little bit. The way the OLEDs work is we do a rolling shutter, we chase the raster. It's lighting up the screen for a little bit, and we are drawing basically as close as we can within scheduling limits behind it. And that's how we get to this super, super low latency on the Gear VR. Now, with the LCDs, the OLEDs change in microsecond or so. They are just super fast. You command that pixel and it lights up or shuts off. But LCDs, the way they work, you say, I'm changing your value, and they take a while to change. Older LCDs could take 20 milliseconds in some cases. Many desktop LCDs, you can see a 2-frame ghost just when you're moving your windows around. The better LCDs now can change in 4 or 5 milliseconds. But still, that means what we have to do is change all of the values with the screen backlight turned off, wait a little while, and then you blast the backlight and everything comes on. So that is a global shutter effect, which is the way Rift runs in most cases. And internally, this used to be one of our great technical debates about whether what artifacts rolling shutter would have versus global shutter. And many people argued that this was just not going to work out well on Gear VR. But now pretty much everyone agrees that it's an okay compromise. You get less latency. There are absolutely some artifacts that we don't fix with rolling shutter, but they're things that in practice don't really matter. Time warp does an interpolation between the top and bottom across time, as well as what your orientation changes are. But if you have something like a long, like in Gear VR, if you had a bar in front of you that was moving up and down rapidly, because it's a rolling shutter, the bar would feel like it's tilted a little bit. If you were moving your head up, the entire viewpoint up and down, Time Warp could fix all that up by moving the entire thing. But if an animation of something moving up and down in front of you would not be corrected correctly. But it turns out that just doesn't happen all that often, and the latency advantage of rolling shutter is a big deal. So when we don't have rolling shutter on the LCD, it means that we've lost some responsiveness, and we should fight really hard to find a couple more milliseconds here and there. We can tighten up the scheduling. We may be able to do some kind of late latching even for attitude to carve a little bit off on the final GPU time warp. But it's still unquestionably a few milliseconds slower than Gear VR. It's still very good, and we're hoping to make it a little bit better, but it will probably always be a little bit more latent than Gear VR. But again, on net, I think it's a good win. The lenses, the optics in Go are second-generation Fresnels, or they might be later gen, but they're newer Fresnels from our research team's development work. I always thought that Rift, the Fresnel trades on Rift were pretty serious. I was pretty put off by the glare effects that happen in Rift when you see all of our early demos. We'd get the nice bright Unreal Engine 4 logo popping up there, and you'd see these fringes coming off in all the different directions. And we have design, that's one of the things, like in Gear VR, one of the design rules you should follow is don't put bright whites in the corners because of flicker sensitivity. On Rift, you should never have bright whites across a black background, not because of flicker, but because of the Fresnel glares. But it does help a lot in other areas. The biggest win for me in the optics is that Gear VR is really only clear right in the center, and if you've got things further away, it's just blurry, almost no matter which way you adjust the focus wheel. And this shows up most in games that have face-locked like HUDs. In Minecraft or Drop Dead, things like that, where you might have information presented around your periphery. I found that strikingly better on the Go optics than on Gear VR. And in fact, it's encouraged me to go back and say, now that we can actually clearly see more of this, I'm readdressing some of my trade-offs around chromatic aberration correction, where in the last couple years, while we shipped initially on Note 4, we had chromatic aberration correction on like the movie screens. We turned it off on some later versions because we were having performance problems on some driver versions. And part of my argument was it's a blurry mess away from the center anyways. The fact that we have chromatic aberration is not the worst thing there. But now that I'm spending so much more time in Go, one of the things that I did last week was re-enable chromatic aberration on movie screens and some really picky fix-ups for things that have to happen. If you're just doing a normal game rendering, you render the 3D world, you might have screens or different things in it, you just turn on chromatic aberration correction and everything works. But if you're using layers, time warp layers specifically to get the high-quality movie screen or the high-quality panel, there are some surprising subtleties to that, where turning on chromatic aberration correction can actually give you more artifacts in some ways. Where this was visible in, you would see blue fringes at the edges of the movies in many cases. And you could carefully blend over it, and they just wouldn't go away. And there's two interlocked reasons why why that happens. One is that when we do chromatic aberration correction blending layers, we have one alpha channel sample that blends this, but we've spread the 3 chroma channels apart. Again, Rift, with lots of computing power at its disposal, does the compositing of layers properly, where every channel gets its own alpha value. This is, again, a case where you do all of these things that Rift does with mirror correction and overdrive and proper blending. Just running in an asynchronous space warp, just running the compositor on from Rift would take up all of the computing power on a GPU on a mobile system, leaving absolutely nothing for your application. So we have to live with these trade-offs. But it's possible to fix a lot of these with design issues. So avoiding the blending problem was a matter of, I used to have a vignette around the screens to nicely fade off the screen. So turn that into a hard-edged, truncated cut. But then you get visible stair-step edges in some cases, and you still have fringes. And this was one of the other unexpected aspects of it. If you've got a rectangle, a screen in space, and it's clipped from the texture coordinates 0 to 1, and you do chromatic aberration correction, what that does is the pixels up in the corner, red spreads out towards the edge, blue spreads out inward. The problem is that red spreads off past the edge of your layer, and that red never gets drawn anywhere, so you're left with only the blue and greens there, which winds up color tinting everything around that. And the solution is to make sure that if you've got a layer that's going to be hard clipped, you need to make sure that any colors that are going to be in there will be inset, say 16 pixels or so that there's room for the reds in the corners to spread out. And this works fine in the cinema, where it's okay to have a little bit of a black border around things, but it can have some trade-offs trying to do it in other panel applications and so on. But still, the net win for the Fresnel lenses. I really love the built-in audio on Go. This is something that it pains me with Gear VR when we try to tell people do good audio, but the truth is most of the people most of the time using Gear VR are just hearing the phone speaker, little monoscopic speaker up here, because it's just a hassle to arrange to dock the gear, plug in your headphones, hope that plugging in the headphone doesn't actually undock the Gear VR if you press too hard, put this on, then put the headphones over and worry about tangling up cords. Somebody that's going to sit down and watch a long show or something, it can still be worthwhile, but it's a huge amount of this friction that I keep talking about getting people into the experiences. And while Rift has built-in audio, I've always felt the little flip-down headphones were fairly awkward for me. It's been a little bit of friction on donning the headset and getting it down, getting it adjusted. So the way the Go audio works is the drivers are inside the main headset, but it basically pipes the audio through the first part of the straps. And an audiophile will probably have some complaints about this and say it doesn't have the best frequency transmission for whatever range, blah, 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 but it really is the optimal for a convenience standpoint. You put it on, spatial audio works, you can look around and hear things spatialized. It puts a lot more value onto doing that. So I count that one as a pure win. You can still connect other headphones to it if you want a perfect over-ear experience, but for 99% of the times people are going to use it, it's a big win. Now, the great thing about having our own standalone headset is that we can address things top to bottom, that it's no longer the barrier between all the different players, where what Samsung's going to do, what Oculus is going to do, what the carriers will allow Samsung to do. So that is one point that wasn't made completely obvious, but this does not have cellular service. And that's one of those really tough decisions that you have to make on a product level, where on the one hand, cellular stores are incredibly enticing, thousands of stores all over the place where if you get your product in there and they push it, they're behind it, you can sell a whole lot of units. But it's usually tied into cell phone contracts and having data plans and all the things there. But the worst part is that you lose control over being able to just completely dictate the user experience. And this has been one part of the enormous set of problems that we have with updates through Samsung. There are so many players involved with this in doing updates. I know Gear VR is a nightmare for system updates. I have this where at my house I've got an older S7 that I occasionally use for playing Gear VR Minecraft at home. But if I haven't used it in 2 weeks, I can practically guarantee that I'm going to turn it on, and there's going to be some combination of an Android update or a Samsung update or an Oculus update. And you know the drill about you turn it on, it maybe updates this and reboots. You try to dock it, Samsung needs to do an update to something. You start up and Horizon is downloading something else. And it's a terrible user experience. And this is something that we want to have high priority on making a lot better. We are hoping the product is designed around if you turn it off every time after you use it, you're still going to have some update problems. You won't get the updates, but I'm arguing for we should never, ever update something while the user is in VR. And if somebody did turn it off every time after they used it, they would never be blocked. They would just keep using the experience they've got. That may not hold through all the way to the end because it gets really tempting when you're maintaining backwards compatibility with things to say roadblock everyone, force them to update. But some of the worst things will get much, much better. Like the problems with driver updates, GPU driver updates. This has been a nightmare. The problem is that we go and we work with Qualcomm and ARM, and we get these extensions built in, but we can't even first get them onto the Samsung headsets. Because Samsung has a whole process they don't take things raw from the vendors. They evaluate each thing and apply different patch sets and so on. And then they don't even go out to their internal builds for quite some time. And then the big problem is that Samsung doesn't even have the power to make these things happen to the users, because when they send out a maintenance release, when they can say, all right, we've updated our kernel, our drivers, all of these important things, or we've got a new OS version, it's still up to Verizon or AT&T or whoever to decide when their customers are actually going to get that over-the-air update. This is going to be one of the powers that is going to be very good for us in the standalone space, where we could decide at any given week to say we're going to replace the kernel or the driver or any of these things. And this should allow extensions and advancements to happen a lot more frequently. And I hope to use this many cases to improve the Gear VR experience, where we can have arguments with Samsung about whether something is a good idea or a bad idea. And I absolutely know our place with Samsung, where Samsung is about selling hundreds of millions of phones, and VR is a small fraction of their business. It's a huge part of what we're doing, but they are perfectly justified in being conservative, not wanting to necessarily jump on things, and to let their most important businesses kind of drive their decisions. But if we can say, we think this is a good idea, look, we already did it, here's the code, here's where you need to patch Android, I think we've got some chances of getting some more improvements more rapidly into some of the Gear VR side of things. This is the multi-view debacle, the way I look at this, where I've been talking about multi-view for at least 3 years here. And yes, it is there finally. It seems to be reliable in the S8s. It's providing excellent performance wins for many applications. But wow, that took a long time. That was very surprising. When the world that I came from, I had such good relationships with NVIDIA and AMD on the PC space. We would do things like say, all right, this is a good idea, let's go do this, and there could be an experimental extension turned around in a week, and we could have things out to users sometimes in just a couple months. Seeing this go all the way to 3 years and still not across all of the devices, probably never will show up on some of the earlier ones, was a very eye-opening experience. And there's an aspect of that that's fed into some of the other strategic things, where some of the problems with the way multi-view was set up, there were some tactical mistakes made in the actual specification that I wish we could go back and change that would have made things easier. But it relied on getting into devices and then getting into game engines and then finally actually getting taken advantage of by new applications. We're working closely with Qualcomm on a foveated rendering extension, which by strategic design is trying to bypass all of those things that made multi-view very painful to develop. It's trying to be set up in a way that we can enable it almost transparently to an application. In general, I'm never in favor of doing things completely behind an application's back, but if we can make it just a matter of turn on a flag in your manifest and we will enable foveated rendering. That's a far different thing from upgrade to the latest version of Unity, change your code to behave this way, rebuild everything, and then it will start working. So there are approaches that we can take that this has been a real change in my viewpoint, where 5 years ago, as low-level PC developer, I was deeply suspicious of any time drivers had to go do magical things, because it was almost always not what I wanted. I was like, let me do the specific low-level things. I know what I'm doing. I'll take care of it. You're going to make decisions that are not going to be optimal for me in various ways. But this 3-year odyssey with multi-view has changed my risk profile for that, where I'm like, okay, yes, the vendors very likely can still make terrible mistakes in the drivers in different ways, but it's still likely to be higher user value if they can make this change, and we can make 500 applications automatically somewhat better, a little bit higher performance in the middle or a little bit better frame rate by using something like that. But for any type of extension, because we own the whole platform now, we're going to be able to roll out fixes and changes and experiments much more quickly. And so that's very exciting. Now, Go is still an Android device. It's Gear VR compatible. I would expect everybody, I would not encourage anyone to develop anything Go exclusive. You should still be considering Gear VR the primary platform on mobile. It will be quite some time before standalone reaches the numbers that mobile has. And this is a point of strategic contention inside the company, but I'm of the belief that mobile drop-in cell phone-based VR is going to be persistent. There are many people that think that things like standalone will take over and will become the dominant form. But I think it's likely that even if we look 4 or 5 years into the future, that mobile cell phone-based VR will still probably have the largest number of users. I think that, again, our software is not great now. As we make our software much better, even the same type of platform will get to be a better, more valuable experience for users. And what constitutes our minimum bar of this kind of Note 4 level of performance, we're going to be seeing that in $50 phones in future years. And I think that there are massive markets where a cheap phone playing VR applications will still have significant value to users as our software ecosystem gets better and better. So Go should not be looked at as a completely separate thing. It really is. Our branding and marketing on this is going to be pretty weird, because internally I can say, well, it's kind of a standalone Gear VR, but Gear VR is Samsung. Go is Oculus. It's a different thing. It's our mobile VR platform, and we need to figure out kind of better messaging about that. But in talking to developers, you should still certainly think about it as one target platform. In many ways, Go is going to be an excellent tool for developers. Because we have this lower level control, we are much less likely to break things that are important for developers, like the various profiling tools or the debugging tools. We've gone through so many generations with Samsung where, well, this tool worked this generation, but on this next rev it's broken again, or it finally works over here. Please don't upgrade anything and potentially break it in the future. We can be a lot better about that. We'll still make mistakes, but because we can actually fix them the next week if we need to. It's going to be important for developers. Now, it's interesting when we consider what the actual use cases for it, where on the one hand, you might think this would be a perfect target. We'll have better control over different things. But because it is an all-in-one headset, I find myself, I set it face down on the table next to me, so I spend a lot of time kind of sticking my face down into the headset to quickly check something, as opposed to the mobile stuff where everybody has their little phone holders where you've just got phones stuck up sitting in front of your workstation when you're working on regular Gear VR things. So there's still a good argument for testing on. Certainly you need to test on multiple platforms, but as development tools, they'll have different values in different places. Then on the high end, again, I'm most excited about Go because it's near term. It's coming quickly. Developers, you'll all be seeing them like next month or something, and then early next year, available to users. But the high-tech side of things with the Santa Cruz prototype direction is, of course, exciting for people that are interested in where the bigger technology bets go. And again, in terms of strategic disagreements or arguments inside, there's a legitimate argument about what is the place of 3 degree of freedom tracking, basically the Gear VR and Go level of things? What experiences and things can people do there versus do we need to have 6 degree of freedom tracking to deliver reasonable value, and then do we need controllers to deliver value? So Santa Cruz is making the bet that it's all the way to Rift spec, essentially, where it's 6 degree of freedom position tracked, dual 6 degree of freedom touch controllers. Go is a couple steps backwards, where it's a 3 degree of freedom controller and a 3 degree of freedom tracked headset. I still pretty firmly believe that there's a lot of value we can deliver at the low end. And this will be one of those things that if we do everything right on Go and goes out and it doesn't get much traction, then we'll have learned something and we will have pivoted permanently probably to the higher end. But I suspect it's going to do pretty well. Realistically, of course, I don't expect Go to go out and do Samsung-type numbers, because Samsung is a juggernaut on all of the kind of marketing and sales and the things that they do. It's been amazing to see the things like, I was in London seeing the building covered with Gear VR and Gear 360 advertisements, and don't expect that from Oculus in the coming year. That level of presence is really a Samsung superpower. But the 6 degree of freedom tracking side of things, the argument that I always make is that a lot of what people do in Gear VR especially wouldn't even benefit from 6 degree of freedom tracking, where the video applications, the 360 videos, 360 photos, even watching things in Netflix or the cinema theater, benefit very little or not at all from 6 degree of freedom tracking. And it is true that this is where people are spending their time. The arguments that we go around in circles with are saying that, I keep saying I made the prediction early on that more than half the time is going to be in these media applications, and it absolutely is. The counter argument is that, well, that's because our games aren't very immersive, that they don't have the real present sense of VR. You need hands to be able to do something in VR, otherwise you're a passive spectator. It's not surprising that there aren't really involving activities there. And it's a credible argument. We have reasonable people can differ on some of these things, and ultimately the market will have out. Will be informed by how people respond to the product. But I think that there's still quite a bit of value there. But still, there's amazing things to be had by getting the full 6 degree of freedom tracking in a mobile space. Everybody talks about room scale VR, but the ability to walk around a large space and have stadium scale, arena scale, or world scale VR, where you can move around and walk behind things rather than navigate behind things. This is, of course, the core magic of VR. This is the really powerful stuff that VR can bring. And it is inevitable that all of this will come down to very low price points in mobile. There are still enough trends on things that, quality of cameras and integration of different things, that these prices are going to be dropping. It is a question of where mass adoption happens, though, and at what price points. I do harp again on, I think $199 is a superpower for Go, and it's unlikely that we can throw all the other things in at once. But when you take that, everybody that's seen the demo, that's playing Dead and Buried, and I do agree that it's possible to take the magical essence of anything anybody's doing on the Rift and the PC and bring that to a mobile form factor, but it is not going to be easy. I make the comment a lot about how a high-end PC might be burning 400 watts of power, and on a mobile system, maybe you're burning 4, if that, in a lot of cases. So a factor of 100 in power difference. It can be bridged, and if you look at, again, Dead and Buried is done by crack internal developers. Andrew and Ryan, the Oculus Strike team people, they know what they're doing. They're veterans. They've been around for a long time, and they bring over the entire essence of what they were doing. You're missing a lot of subtleties in some of the graphics, different aspects, but you can get the core magic. And it's possible, but it is a lot of work. And again, like my talk at the beginning, it takes people buying into some of these skill sets that are not necessarily being exercised very much right now. If you're interested in seeing that level of interactivity and performance, you might as well start by sprucing up some Gear VR level things, because that's performance, relative performance levels that you have to deal with. Some of the things that are interesting from the standalone engineering side of things. I've often commented that mobile performance, you only get kind of half or less of what you think that you would get, and largely that's because of thermal limits, and everybody's had the issues of Gear VR overheating. And I stress about this a lot, where everybody, each time we get a new generation, like the S8 is a lot better. And people say, well, we want to do more aggressive graphics. And I'm always like, can we just hold back and instead have a device that never overheats? It's a balance between saying, well, I really want to add my specular highlights to this. And I'm like, well, I really don't want to overheat and have a user say, well, my device just kind of crapped out on me. This is not very good. But with proper cooling, it is possible to run the devices at their maximum or very high clock rates. But that's one of those engineering changes. Do we put on active cooling and have fans blowing over this? And certainly we're going to have lots of this computer vision work going on to track the world, to track the controllers that comes out of the minimal hardware that's going to be there and driven by the battery. So there's a lot of trades there. Some of the other interesting aspects of owning it, like a discussion that came up, one of the problems that we have on Gear VR is lens fogging. One of the reasons why it's less of a problem on Rift is you'll notice that the Rift stays kind of warm. If it just sits on your desk there, it's burning power. It's probably burning as much power as an active cell phone when it's sitting there idle for the cameras in the Rift itself. But that actually keeps the lenses from being as much of a fogging problem, because the temperature of the lenses determines when humidity or sweat condensation will wind up landing on the lenses. That's something we've talked about for Go, where maybe we should, if you've got it plugged in, if you have it on the charger and plugged in, we should drive the screen, turn the screen backlight on, but leave the pixels all black, so it generates heat into the device and notably keeps the LCDs warm, so they're going to change faster. We have concerns about various low temperature conditions for the LCDs as another trade-off against OLEDs. One of the other great things is having our own operating system team that we can now track everything down. Like, it's been so wonderful for me to be able to say, like on a Samsung phone, you do a systrace, you get a list of everything that's going on, and I just stare at it dumbfounded, like, what is all of this crap running on my phone when I'm supposed to just be in VR? And it's things, like, why is Amazon Videos doing something in the background when I've never downloaded it, but it's a carrier preload for something? And all of that's gone on Go. I mean, on Go, you get a nice list of here's all the processes. They're all Oculus processes from a few basic Android processes. And that's really great. And now to get some of the really great kind of kernel ninja types inside Oculus, being able to track down, well, why exactly is this interrupt blocking this other thing, and we're being schedule delayed for various reasons. So that's been really good. So back onto the Magic software side of things, my big win for this last year has been VR Shell, and it's something that we haven't talked really explicitly about a lot. We just kind of rolled out, hey, there's changes in all of our first-party apps, but a bunch of the people that hung around with me after hours last OC3 got to see sort of the preliminary version of that, where for years I'd just been saying I was so frustrated how so many of the applications just look terrible, and I had this litany about nobody, not even Oculus first party, was doing like a good job presenting text in VR. I mean, it pained me deeply how Home was an aliased mess of unreadable text when you started up. I can't just point at our own applications and say, do it like we do this. Everybody would say, well, this is what VR looks like. They would get baselined by, they put it on, they look at Home, and the environment's aliasing, the text is hard to read, all these problems. And I think that that hurt people's expectations, and then people wouldn't even strive for better because they figured, well, Oculus is probably doing everything right. If I look like that, I'm probably doing everything right. But Oculus was not doing everything right. And I had laid out the plan for years. I would say, you always have MSAA on. You always want to have blended edges on text. You never want to do a hard discard there. You want to use sRGB. You want to use a custom time warp layer and have the resolutions carefully matched. And if people followed like the app critiques that I would write up, I would say this for years, over and over, about here's the steps to go make VR look good, but very few people would actually follow them. So last year I was showing people just this little demo that I had where I took the top 99 applications in the stores, like 99 random applications, and I had a perfectly pre-filtered environment map, and I used a cylindrical time warp layer, which was the one new bit of magic that happened about that time last year, where previously we had environment maps, we had flat planes for movie screens, but the addition of cylindrical layers was a surprising goodness, where the lenses have a distortion where you have less detail on the sides, but curving around you, not only does it feel nice for VR, but it almost magically corrects for the distortion of the lenses and makes for an even pixel density. So I was using that new bit of technology and then just doing all the things that I had already been doing before. And it looked magnificent. It looked so much better than what we had. And so internally, we always had this long battle between doing things like in Unity, and Unity's a wonderful place for doing game engines, but I've always said Unity's not the most appropriate tool for doing a media browsing system, whether it's for videos or applications or whatever. And what I pitched was a new environment that I was calling VR Shell, where it would handle two-dimensional user interfaces and minimal 3D and environment things. It would be focused on the user interface side of things. And a point that I would make was that two-dimensional user interfaces are unreasonably effective. Everybody's surprised that they think, well, we have to be pulling things in and out, we have to spin things away and do crazy tilty 3D things. And almost all of those turn out to actually be negative for the user value experience, about being able to find what you're looking for and be sold on the value of what you're looking at. So I was proposing we push it all to basic 2D interfaces, basic 3D environments, but we have them all done right. We guaranteed that the pixels are going to come out as good as we know how to do it there. We're going to efficiently handle the loading of the environment assets. And then because it's going to be an environment, a system here, we'll be able to switch between applications seamlessly. No fade to black, load up another application, but instead, you want to go to video, it's here. You want to go to browser, it's here. You want to go to Facebook, it's here. And then we start delivering synergies there, where you can be in Facebook, you can click on a link, it goes to browser, you can download a video, it goes to video, using kind of our optimal presentation tools for all of this. And this was there was a lot of kind of institutional resistance to changing what we're doing, the way we're building our applications. And I cheer that this really was, I think, my big win for the last year, getting our applications migrated over to this new platform. And I think that this is where a lot of our future value rests. Not only does it look much better, but we are pulling in these synergies. And the one thing that hasn't made it in yet, that is our big focus for the rest of the year and towards Go launch, is that Shell was always pitched to be a social substrate, where we've seen enough experiments now where different applications get built for, we have spaces, and we have all the other places that other companies have made social applications. And there's a trajectory that all of these things have, where you build a social space, you've got a chat room, you have a couple of things you want to do there, but then everybody wants to make it expandable. You add a plug-in architecture, you add some way to start doing other things. And I contend that that's backwards, that instead of building a social place and then hacking applications on top of it, I have proposed with this that we build an application infrastructure that has social built in. And there's going to be trade-offs involved. It's not going to have every nifty little social feature that the dedicated social apps have. But my bet, the play that we're making here, is that having good enough social that's always there, that can be a simple click away, not an app launch and browsing and doing all the other multiple steps. Again, that friction funnel that keeps people from doing things. This is core behind what we're doing with venues. There's still a directional bet that we're making here, where we're starting off with venues being stranger-focused for large events, because there's still the shallowness of the friend graph. It's hard to find people that have 2 or 3 friends at the same time that want to go do something. But fundamentally, it's not venues as this separate product. And internally, I've had this whole problem with how we look at it internally and position it externally, where it's not much of a product itself. It's really just enabling the Shell core in VR, the social core in VR Shell. And Venues is going to be a trivial video playing app, essentially, that works with this. But eventually, all of that stuff should be available everywhere. And people will say, well, what's the point of letting 10 people join you while you're looking at your home screen? And there's probably plenty of things that don't make sense, but even like browsing through the store, being able to have somebody sitting next to you, watching you page through the stuff in the store and pointing out different things, I do think that there's some value there. Shell is a multitasking environment. When you pop up the keyboard for typing in a URL or doing a search in home, that's a separate, we call them panel applications. We talked at the beginning, we started off making home actually 3 separate applications. We were going to have social and store and recents, or different things like that. Turned out we didn't do that, and the landing page is one big application, so it has the freedom to rearrange things in different ways. But you do have the ability to do that, and we're rolling out a new interface that's going to sit below a lot of the applications to provide common things that everybody wishes we had, like easy ability to see the time, see the battery level. We're going to have a universal bed mode in Shell where you can just pull any of the UI, so you can lay down and browse the web or Facebook on the ceiling while the environment around you still stays properly referenced without going to a void theater system. So I think a lot of these things are going to be very powerful. There's still a few pieces, like I wince every time now that I see the old pieces of system activities when you have the quit to home or return to application mode, which is still not in layers, blurry, low resolution. All of those things are going to eventually be part of the home VR Shell system that all applications will be able to take advantage of. Now, the actual programming model for the Shell applications, this does mark the second time now where I've kind of failed to bring in a radical change in program development. The first one was with the VR Shell stuff that I was talking about 2 years ago, and that I thought it was a pretty powerful and compelling, like the demonstration, the live coding that I did here. But internally, the general thought was, well, nobody really is going to want to use Lisp or Scheme, the racket system that I used, so it should be JavaScript. And we started hacking together a JavaScript version of that Michael Antonov did a lot of work on. But then it's like, well, if it's JavaScript, then it should really just be WebVR. And we spin up the WebVR team, start working on all of that. But my hope of 2 years ago, being able to have this super simple, easy to distribute, simple VR application model, we've lost that. And I have a guarded kind of relationship with WebVR, where in general, it's never wise to bet against the web and the open standards. I think that we should support it as well as reasonably, but we have some passionate WebVR advocates internally, and I'm always trying to steer them. It's like, no, let's build better stuff in VR Shell rather than spending a lot more time on WebVR. There's reasonable arguments. Reasonable people can differ on the priorities there, but I want to make my play on let's do the best thing the hardware is capable of on our systems in VR Shell, rather than spending lots of time on WebVR stuff, which has to work on various lowest common denominator systems. But then the second one, when I started on the VR Shell system, it's one core application, but it loads and communicates with each of these separate panel applications. The first thing that I was trying to do was set up, well, what is the simplest, fastest sort of application loading switching system I could do? And I'm like, well, all right, I'll spin up these services, and then I will literally DL open and load shared object files. And I could set things up so I commented it's like virtual reality like it would be in the 1990s, where you've just got you've got your C++, POSIX, OpenGL, OpenSL, and you write these simple things, and it's one simple little make file. And it had these half-second turnarounds. Applications could launch and show their first frame in 50 milliseconds. And for the low-level developer like me, I loved this. I thought this was amazing. Instead of a whole directory full of stuff to build your project, you could have Hello World look like one file, one C++ file, one make file. And some of the simple applications that I did had these magical response rates, all these high qualities. But it didn't even last a couple months before people are saying, well, we need to load Java code. We need to load all of this stuff that our applications depend on. We need all of these other libraries. And it very quickly slid into panel applications are now full Android APKs, which makes me sad. They've got the whole Gradle to build, and takes longer to start up, and people do take the opportunity to pile in lots of Java, JavaScript interpreters, and all these different things. But it's probably the right thing. It's more important for people that have large, extensive, powerful code bases to be able to easily retask them for this than to be able to build these brand new from scratch, super efficient diamond jewels. So where we are right now is what a panel app is an Android service that an APK provides. VR Shell launches it. You can give it a surface to draw onto, which we can take care of positioning in 3D, and there's a command channel to do things like changing the environment behind you, loading up different models, playing videos, all sorts of different things like that. And so I hope that type of annotation, this is one of my other kind of uneasy relationships with WebVR, is I think that there's this great possibility of doing super trivial website annotations where instead of adding a big thing, if you want to add a little bit of flavor in the browser, we should be able to drop in one line into an HTML file, which is basically, send this environment command to VR Shell. So everything else ignores it, but if you're browsing in VR Shell and you go to this page, it changes the environment around you. I think that there's some great low-hanging fruit that, again, the friction funnel, if all it takes to make your website a little bit more VR spiffy is put one line into your HTML file and point it at a 360 photo somewhere, I think that's the type of thing tens of thousands of web pages could reasonably do. If it's a matter of rethinking it for some virtual reality experience and writing a mini game engine in WebVR, that's something that I don't think many websites will actually go out of their way to do. So I consider VR Shell so far a pretty big success for us. We have lots of work going on to develop it. The intention is to become this next computing platform that you can do everything that you would do in a traditional computing environment in VR with high quality, with good responsiveness. And there's lots of active effort going on with that. So going forward, if that was my win for last year, my goal for this coming year, really the second half, is to make a similar step in the quality of our immersive video. The power of a really good 360 video in stereo 60 frames per second, high resolution, is really high. And we really lost something even from the very earliest Gear VR Innovator Edition. One of the things that I was so happy about there was that we had the little pack-in SD card that had 16 gigs of media on it, including some high-quality 360 videos. And you looked at those, and that was many people's first impression, and it's a wow when you see something really great. In contrast, now, if you start up Gear VR, you go to Oculus Video, and you watch some 360 videos, it's just not that great for a lot of different reasons. And I think it's fixable. I mean, I think we can make what I hand-wavingly call about a factor of 2 improvement in the quality of what most people see when you just go through that process. You go through and say, I want to go watch a 360 video, browse through, find something, play that. It should just come out a lot better than what we're giving today. And one of the things that I also think we can improve on that experience is some of the stuff I've been experimenting with are more user controls inside video playback, where I always regret in just normal video players when you don't have things like frame advance and frame back. But in an immersive environment, it's almost a godlike power when you've got all the 360 stuff going on, you're like, freeze, forward, 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 jog backwards smoothly, go forward. That's a really powerful feel, which plays to some of the strengths of virtual reality. So I've spent a lot of time in the last 6 months kind of leveling up my video skills in a lot of different ways, reading all sorts of ISO specs and writing implementations of different things. Now, I can't magically make a crummy 360 video look great. Although there is some interesting research opportunities and things going on with using machine learning to do things like super resolution, and frame rate interpolation is a reasonable thing to do. So there potentially is some room for magically make bad videos look better, but what I'm concentrating on is reducing the delta between what's actually captured and then what the user sees, because there are a lot of steps between that right now that do a whole lot of damage to it. So there's kind of 4 things that I'm working on that make a big difference on video. One, the simplest, most obvious thing that hardly takes any effort is just allowing users to take advantage of the bandwidth that they've got. We see Facebook does all of these surveys about how much bandwidth users have on average. And if you look across the main Facebook applications, you've got all these across the developing world, people that are on tiny little straws of bandwidth, and things that they do for videos. They have very low quality versions of things. One of the things that's really a shame right now that needs to be addressed is they have all the different levels of video quality, going from, in some cases, 4K down to these little 160 by 120 thumbnails. But there's a single audio track for anything that gets uploaded to Facebook with a single binaural, with stereo audio. The 360 audio is much higher quality. That's got a lot of bit rate. But if you just upload a big video, even if it's a 4K video and you upload it at 100 megabit per second master quality, the audio is coming down to 50 kilobits per second. And most people would say that even with good compression and everything, you should have 100 or maybe 150, depending on the codec that you're using. So audio takes a pretty big hit there. Again, changes in priorities. When all you've got likely is a little Gear VR speakerphone speaker, maybe that's not such a big deal. Now that we're focusing more on Go and everybody's got good, reasonable quality stereo audio, we can care more about that. So we look at the bandwidth rates, and lots of people on browsing the web or the Facebook application may have very low bandwidth, but the Gear VR users are way up there. They're people with premium smartphones that tend to have much better bandwidth. And the highest bandwidth version that you get from a video that goes up to Facebook is usually around 10 or 12 megabits per second. And that's somewhere around our median bandwidth for users. Like half of our users have significantly more bandwidth than that. So the easiest thing to do is say, well, let's just allow them to have a 20 megabit per second or some other higher rates there that let people that have the better bandwidth just magically get better pixels. So that can be a big help. The other thing is the newer phones. Since the Qualcomm S7 and all of the S8s, the codecs have the ability to decode 4K video at 60 frames per second. The earlier phones were limited to 4K at 30 frames per second, or the quirky aspect way back on the original Note 4, it could do 3840 by 1920 at 30, but 4K by 2K only at 24 frames per second. So encouraging more videos to take advantage of this greater headroom that we've got on the newer phones. Then one of the things that's bothered me since the very beginning, the original Note 4 releases, the frame release tempo on the videos has not been perfect, where I say 60 frames per second is magically so much better, but if you play a 60 frames per second video, it does not come out one-to-one video frame to display frame. And interestingly, this is something that got a lot worse, where on the original Note 4, there was a tiny tick of about 1 frame per second would get missed when we were using the Android Media Player. And I was heartened because I had noticed that, and the Felix and Paul people pointed that out. Hey, what's the deal with this little tick? And I was heartened to find that anybody else actually even noticed that. So that wasn't a huge deal, but I always thought, well, what needs to happen is instead of locking to the audio time, you need to lock to the video time and then slightly resample the audio rate. Because the videos are mastered at either 60 or 59.997 frames per second, but the cell phone displays have more variability than you'd think. There's 1 or 2% variability in the video frame rate, which means that you can wind up dropping a frame every second or two just to compensate for that. But if you instead match those one-to-one and resample the audio, then you can have it this perfect, every frame is a new one. If you don't resample the audio, then you find after 5 minutes that you've got this very long voice delay between what's going on the video and the audio. So I had wanted to do that for years. That had been on my on my hit list. I'd been trying to nudge other people to looking into doing that. But this year I finally sat down and said, all right, I'm going to address a lot of these video problems. Then the last on the pre-processing side is avoiding resampling in as many places as possible, where this was one of my keys to the super high quality text in VR Shell, where conventional VR rendering is a matter of rendering something to a flat 3D, rendering your 3D world to a projection, and then we distort the projection onto the screen to account for the lens distortion. So that involves an inevitable loss of quality. Even if you put the eye buffer up to an insanely high for mobile resolution, even if you ran it at like 1536 by 1536, even in the center there, you would wind up having a double resampling of the images. And of course, on the outside, you'd have aliasing. So shell is great because you draw to a flat image directly on your text instead of a random floating place in 3D world. And then that one gets resampled one time as it goes to the screen. Now, videos get resampled a lot of times in the process of kind of becoming the final pixels on your screen. It starts out that when you take a video on a camera, it's going to be saving it out in some compressed form. Whatever comes off the camera, hopefully it's at a very generous bit rate, but that gets pulled into a program to do some stitching with it, and then to eventually do whatever post-processing effects people go onto it. So it gets decompressed there, gets resampled into an eQuarrect, and then saved out and delivered to Facebook or wherever it's going to be uploaded. Often there's multiple steps in between. Often it will be a matter of master at a high resolution, then resample that down to a lower resolution before going to Facebook. Then once it went to Facebook, we would resample it to a cube map of some kind. And this is a legacy of some early decisions that happened. And, speaking of early decisions, one of the things from 4 years ago that I still get to kick myself fairly regularly for, when I defined the cube map format, the cube strip format that we used for 360 photos, it's actually inverted. And we ran into this in Shell where, all right, we take photos inside Unity, or 360 shots inside Unity, they're like this, but all of our thousands of 360 photos that are already up there on the web served to 360 photos, they would all be like rotated and backwards, and worse for 3D videos, they would wind up eye swapped when you use the wrong one. So we have fix-up code dealing with this. But the reason we used cube maps initially was two things. One, everybody knows eQuarrects waste a fair amount of data on the top and bottom. You've got these massive pole spreads, and it's about 30% more pixels that if you treat it as a cube map, you still have unequal distribution. The corners are much higher resolution than straight in front of you, but it's still about 30% better than eQuarrects. And then the other aspect was being able to do the direct time warp sampling. Now, it turns out for videos, that hasn't been that important of a thing, because the direct sampling only really matters when your resolution is high enough that you're getting close to the resolution of your display screen. And we've always been a long way off in video resolution. But those were still the reasons that we did that. But the resampling means that you've probably noticed in 360 videos that sometimes you'll look one way and you'll see kind of a little stair-steppy artifact visible at the edges where things were resampled to this cube map. We should have been able to fix those by just slightly expanding our filter to overlap it a little bit. But the larger point is that every resampling does some damage in some way to the imagery. So turning it from an eQuarrect into a cube map, even if in theory it covers the same number of pixels, you take your 4K cube map and you turn it into a 1280 by 1280 cube map that in theory even has more resolution in the cube map for most of the areas, but it's likely still going to be worse quality than if you had used the original one. And it's especially worse when compression is involved, because every step of these winds up getting compressed. So you H.264 compress this, and you get macro block artifacts. So you've lost high-frequency components here, and you've got kind of a blurry block. Well, then you resample that, and you've got that blurry block that's now stretched across 4 blocks that gets recompressed. So you get multiple generations of compression artifacts kind of baked into it. The ideal world would be if you took something from a camera and the direct raw images from the camera were then projected appropriately into virtual reality. And it's possible to get what I've been chasing with video quality for years now is display limited resolution, where we have some media, like our 360 photos, that are at a higher resolution in some areas of the screen than what the physical display, the 2560 by 1440 display on the devices is. And some of these, like the best 360 photos made by the photographers that really know what they're doing and have done everything right, and certainly the synthetic ones, like all the Otoy render the metaverse images, these are still the finest looking things that you see looking through a headset. And for years, I've been, if only we could make these move, if we could have this quality of pixels and in our videos, that would be a really magical thing. It would be very different than what we've got now. And just a few weeks ago, I started doing some tests. There's all the ways that we've chased this. We had the view-dependent streaming was our big bet that we thought was going to allow us to get display-limited pixel quality in the middle. And the way that would happen is content creators could upload a 6K video, like a 6K by 3K video, and then we made 20 different versions of this, depending on exactly where you were looking. But it really did turn out kind of disappointing in that you'd be looking here, and if you sat there and you only looked straight forward and you got to the right quality level and everything, there were a number of things that had to happen to turn out right. But sometimes it looked really great. You had extremely high quality. But what almost everybody would notice about it is, well, that's interesting. I look over here, and now it looks like garbage over here for 2 seconds until it winds up picking up that stream and streaming that in, and then it snaps into a super high quality. And that was very much a mixed bag, and I think most people decided that it was a net negative. And this is something that we could A/B a lot in terms of how many people watch longer videos if we turn that off and just give them the cube corner, like our best other projection, versus that. And the truth was, people would give up watching those because there would be more hitches in the display and the differences in the video quality. So that was not going to kind of give us this magical quality level. But something that came up just a few weeks ago, Matt Hooper had been working on the idea of like, well, what are we going to do for our in-store demos for selling Oculus Go's? There's questions of, do we just have an app launcher? Do we have some kind of intro to VR video? What do we want to do? Well, we really want to make the best possible quality that we can put. We want to put our best foot forward there, get the highest quality videos and different things that we can mix in some 3D environments. But we started talking again about my quest for this display-limited resolution. And we were saying, well, if we wanted to just do an experiment about what could this look like if we just, everybody knows now that if you go from a 360 to a 180 video, you double your pixel quality, and that's a pretty big step. And it's like, well, what if you drew it in even more? There would be some point at which you would be at the display limited resolution. And by kind of a happy coincidence, it turns out that just regular GoPros, one of their resolutions where you're at 1920 by 1440, that's at a 90 degree by 120 degree field of view. That is almost spot on to what Gear VR's actual resolution is. So, Matt went and set up a couple GoPros, did the type of thing that probably dozens of you in the audience have gone and done, set up a stereo camera rig, worked out the syncing stuff, and started taking some footage with that. And I played this with all my latest code. I call the new suite, there's Video Direct for the playback part of it, and then I've got Dash Direct for the streaming and Multi-Streamer for doing multi-socket streaming, all these different things. So I plugged it in with the Video Direct backend, and it looks pretty amazingly good. I experimented with a few different edge treatments. There's like a 3D model around the edges, or a properly positioned 3D fade, or just showing the raw camera edges. And I've been showing a bunch of people around here. In fact, like 1 minute before they pushed me out onto the stage here, I was showing one of the producers that did all of the kind of stage production work here. Now, this is what our video should look like. This is what's possible. And it gets an amazing reaction. And probably 20 or 30 people have gotten my S7 passed around to see this while I'm here, and I'm here certainly the rest of the day, and more people will see it. And I'm looking at this as this is very much like what I did last year, and if I can keep this going in future years, this will be great. Show how text and imagery should look last year, deliver VR shell, show how video should look here, and deliver massive video improvements next year. But it reinforces to me that there is magic there, that there's something very powerful. Getting locked stereo, locked 60 frames per second, having everything work perfect without the glitches, without the artifacts at that resolution, it's really a pretty big deal. And these were just GoPros, where professional lenses, professional lighting, you could stretch out the fields of view. Even if you weren't doing any more tricks, you could go to, that's not maxing out the codec resolution. You could go to maybe 160 by 120 or something and still have this exact same super quality. To go beyond that, we start looking at many more kind of tricks and games. We can do more projections if we don't mind a resampling on the way. I have some some hardcore H.264 bitstream hacking stuff that I want to do for people that have location-based things that don't care about maybe loading up gigs of video if I can rebuild synthetic bitstreams on the way. So there's possibilities there. But again, put all of these things together, avoid resampling, use the bandwidth people have available, take better use of it using multiple socket streaming, so on. And the way I'm doing all of this is for this narrow path. We use Exoplayer for most of our, almost all of our video work. It's great software, open source from Google. Most of our video stuff is based around this. But it's a big Java application that doesn't specifically cater for the like the super high-res videos and things that we're doing. So for this narrow path, I have custom code that my goal was to own it from kernel sockets to media codec layers, and everything in between, not having anybody else's code. So for the specific cases, I can wrap all of this stuff together and have a much, much better quality presentation. We are piecemeal putting some of this into the rest of the systems, where the video direct kind of backend, the video team has replaced Exoplayer's general backend. So a lot of things get some advantage from this, but they don't get the frame locking and resampling, and then they're not using the multi-streamer side of things, lots of other stuff there. So we're going to have tiers of different things, but the most important thing is that in the not too distant future here, side-loaded MP4 videos, if it's in MP4 and it's a local file, playback will get a lot better for 4K 60 for these very demanding things. Instead of copying through an intermediate buffer, it's directly rendering it. It's very power efficient as well as being very, very frame locked. You can play a 4K 60 video for something like 3+ hours sitting there on like on an S7 class system. So there's interesting possibilities there, as opposed to trying to play 4K 60 video. Right now, it's got this terrible tempo judder problems where it'll be smooth. If you watch like the great Felix and Paul stuff, we've got Emmy Award-winning videos, and I look at that, and it plays smooth and goes stutter, 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 smooth, stutter, stutter, stutter. And like they're saying, like typographers can say, if you hate someone, teach them to recognize bad kerning. How the letters aren't necessarily spaced correctly together. Well, I want to teach everyone to recognize bad video frame release tempo. When you're looking at videos and you're watching something moving smoothly, and then it glitches a frame, and then it goes on. When we were running the main keynote, and we have all this animation, I'm critically looking at this going, all right, they've got the frames right. They're not dropping frames. When I was at GDC earlier this year, they had a similar super expensive high-end video projection system, and they had the same damn tempo release problem. Animations going on, smooth, stutter, 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 smooth. Usually it's like smooth and then a little glitch as you're going from 59 to 60, but there's a problem when you've got asynchronous time bases where you fall into this smooth and then stutter, and the graphs look absolutely terrible from it. But there's good quality to be had from this. On the content creation side, there have been a lot of interesting learnings and surprises as we look at the data. And as part of Facebook, and we've got a great kind of analytics team on some of this, there are some interesting insights that you get from really paying attention to what people are actually doing. Some of the stuff that people never would have guessed 4 years ago, things like roller coasters are unreasonably effective with people. I mean, it is shocking. Not only do people watch the roller coaster videos, they go back and watch them again and again. They're some of the most replayed things, which violates all of the basic wisdom about like what a good VR experience should be, focusing on comfort, not doing the locomotion, not turning in parabolic arcs and different things. But, the honest truth is people are doing them. They'll watch them, and then they probably go around, they show their friends and all these other things. Another one is horror genre, where that makes sense in hindsight, that putting someone in an immersive virtual environment cut off from the world, that what makes horror tick as a genre can be much more effective there. And horror has never really been my genre, but I recognize the effectiveness of this in many cases. I know like most of the Face Your Fears was fine, but the creepy bedroom scene on there, I'm like, I just don't want to see the rest of this. It's impactful enough there for what it's trying to do that it has a powerful effect. And a lot of our videos, just in 360 videos, are similarly very high ranked with horror genre. some of the stuff that comes down to kind of brass tacks on development, where the dramatic stuff is often very popular. The Lego things are always very high on our rankings, the Lego Batman and so on, Lego Star Wars now, but it's very expensive to produce those, high quality 3D rendering. But things that are also often very popular that are dirt cheap to produce are things like the animal videos. Nature videos, somewhat less so, but then putting actual animals in there and letting them come up right around the camera. It's basically cat videos sort of thing, and that is also remarkably popular in VR. One of the things that Google announced that I thought was really important, and I'm kind of disappointed that I haven't seen more aggressive follow-up on this, because I thought it was potentially one of the really great ideas here, was pushing more on the 180 videos and allowing it to, if we can convince people that do normal things like on YouTube or whatever, if instead of just having the one camera pointing at them, you put a dual 180 stereo camera, but you automatically pull out the appropriate 1280 by 720 center part to send to everybody that's watching it normally. That becomes something that you serve all of the existing customers, but then, please stop flashing me, go to QA, I'll get it in a minute. But then you get this wonderful immersive experience that really is different. And if you, especially at 4K 60, it is at that distance, when you're just like 3 feet away from people with good quality, it is a magically different experience. And I think that's an opportunity to get immense amounts of content. And that seemed really brilliant at the idea, and I think they did a few trials with that, but I hope that rolls out really broadly, because almost everything that people wind up doing, cinematography or videography-wise, we have all these things that we know how to do, pointing the camera at it. And some of the things that wind up being surprising, talking about people that go through the work of 360 production, is that you think about like all the challenges about, okay, obviously you can't have your set stuff back here, but you can't have your director sitting behind the cameras, which is something that directors are used to being able to do and kind of direct the action in various ways. And there are all these challenges with 360 where there's certain things that 360 is better than anything for. When you put yourself in some wonderful environment and you look around, you appreciate the whole thing. But it really does seem likely that that is a subset of the things that people want to experience. And we also find that, unfortunately, people don't turn around nearly as much as we kind of wish they would. For years, I preached the virtues of swivel chair gaming for Gear VR, that this is, the way to have the most fun in a gaming experience is to either stand or sit in a swivel chair and be able to turn around 360 degrees, chase the action wherever it's going. And I think the best games are still like that, but the vast majority of people want to sit on their couch and have something happening in front of them. So I think that there's an excellent opportunity for taking things that you're going to present normally in a rectilinear format, but then also producing for free, essentially, a high-quality, immersive version of it that you can get with almost no extra work. Because production costs matter. We start looking at these and say, all right, it's great that we won an Emmy for The People's House, but that was really expensive to do. Everybody can't build content like that, and YouTube has certainly shown that a lot of surprisingly low-budget, inexpensive content winds up being extremely powerful for people and makes a big impact.
Ladies and gentlemen, please welcome CTO of Oculus VR, John Carmack.
Hi. So this is a little weird coming out for a keynote after having spent literally 20 hours over the last few days talking to people in the rooms and halls. There's so much information to go over, and I did take a lot of notes from everything that I hope to be able to say here. So I broke with tradition, and this morning I sent an email saying, I don't want to make a fire drill out of this, but how about, would it be possible if I get some of my notes up on a screen? So I actually have a clicker this year to get through things. You know, maybe one day you'll even get a PowerPoint out of me. But, so, as usual, this isn't a visionary talk. I don't want to speak about where we need to be going in the distant future. I'm happy with sort of the Oculus vision of do anything, anywhere with anyone. And I think that's a goal that we all kind of buy into about the promise of VR in the kind of hazy future. But one thing that Nate actually said recently that I thought was a little more pointed was, it's our job to get from the point where you're crazy to have a VR headset to the point where you're crazy not to. And a few years ago, you really were crazy to have a VR headset. There was almost nothing to do on it. It was a very fringe thing. We're a little bit past that point now, but if you look at a cell phone today, you're crazy not to have a smartphone because it brings so much value to your life. There's so many things that you can do with it. We're not at that point yet with virtual reality. My hope is that sometime in the coming years that we'll be getting there. But right now, this is about hard work and details that matter. VR apps are hard. Everything that you have to do for a normal application, you still have to do with a VR app. Plus, you've got performance constraints, and you have these other physiological things dealing with your eye strain and comfort that you don't have to deal with in normal apps. So it's a lot of work, and there's unfamiliar factors that we're still learning. Now, I really am here to help. I've tried to be as available as I can so far through this, but we're going to run out the clock on this. I'm not leaving till tomorrow, so I'll be available. I'm at your disposal for the rest of the evening tonight. So the good news is that Gear VR is really succeeding beyond expectations. It's doing quite well, and I think that we're really at a critical mass right now. We made an announcement that we have 1 million users, active users in VR in a month. And I caught somebody that actually read marketing smarm into that wasn't there. That wasn't like when 1 million were given away, there were 1 million people. This is like month after month and picking back up. So there are a lot of people actively using VR. But also, there are a lot of people that got a Gear VR, tried it, had a good enough time with it, and it is sitting on a shelf. So there's even more people that are available for resurrection here. The market is actually quite large. I guess we've decided not to say, for whatever reason, exactly how many are out there, but it's a lot. And there's people that are doing quite well with this. So it's exciting, and I think that there's sort of a critical mass here where there's probably every media company has somebody that's got a Gear VR or access to a Gear VR. People can be looking at it. And I think it's possible to write a killer application on the hardware that we've got right now. This is not a universally shared opinion. There's, if you're on the hardware side, of course, you're thinking, well, hardware is the key to the future. We have to build new hardware that has new features that will enable things. But I really do think that the hardware that we've got right now, it's possible to do an application that really launches the VR age. I think that the gap between what we see in a typical application and what's possible at the limit with the hardware is really quite significant. I think that if you look at the best things that you can see in VR, and I still think that probably the best image that you're going to get in VR, really across anything, is still the synthetic OTOY images that we have in 360 photos, where these are pre-rendered images, but you look at them and everything looks flawless. It's perfectly anti-aliased. You look around, it looks great. Now, everybody just assumes that the actual application, a real application that's not a photo, is going to have all of these behaviors that we associate with VR. There's going to be aliasing here, things looking messy, not responding particularly well. But it absolutely is possible to reach that level of pixel-perfect fidelity if you're careful doing certain limited things. So first, I want to do a quick recap over the topics from last year with some updates. So I had my sort of top 3 or 4 things that I was pitching and working on last year, and I talked about a lot of them. Number 1 was Minecraft at the time, where that was our big triumph of we had the final meeting, and we had announcements just before Connect last year that Minecraft was a go. At that point, I had a version that was running, and I was like, okay, go, launch now, launch this, what we've got right now, it's great, it's good. But the Minecraft team coming onto it, they were like, okay, let's hold back, we need to get our footing here, figure out what's going on. And I was worried for a while whether they were even going to let me work on it, whether they were going to want to really take it in a different direction maybe than I thought that it should go. But it turned out, it all worked out great. I was able to go ahead and bring back my old, the stuff that I had done earlier, modernize it in their code base, and then kind of help and direct them through kind of all the updates that they wanted to do. There was a little bit of tension where I would have released what I had right there if it was up to me. And it's worth noting that, as I'm going to speak a lot about aliasing and pixel fidelity quality, Minecraft at that time would have been the most aliased thing on the store. It would have had aliasing between every little blocky pixel there, and I still would have said it was valuable to put it out. So everything that I'm saying about rules and kind of the way to do things and guidelines, they're all still guidelines, and it's certainly possible to have the value of something outweigh things that are negatives. But we got a lot of good things out of it from by the time it did ship, 6 months later. I was hoping for like a 2-month release time, but it took 6 months to get through it. But over that time, it was great to see the Microsoft team buy into Gear VR. At the beginning, I was talking about the virtues of having a swivel chair and being able to play the game like this and the value of the portability. But most of them were Windows developers. So of course, they're like, well, we're going to do the Rift first, and then we'll see maybe about this Android Gear VR thing. But over the course of the development, the kind of value of that swivel chair play and the portability and things like that, the team got it. And I'm really happy with our working relationship with the team since then. I was happy to do E3 promos and go to Minecon with them. And this is a relationship that should be going on great for a long time. Because it's integrated into their core code base rather than just being a VR version. Like they've done versions of Minecraft for some other things, and then the code bit rots and it's unsupported. But this is built into the very core of everything that they're doing. This is by far our biggest title, kind of the most important. I mean, Minecraft is arguably the most important game on the planet, and I'm really happy that we've got it on our VR platforms. I play with my family every week. Every Sunday we get in, it's our family tradition, and we get into our realm and we play Minecraft. I drag out my swivel chair and spin around in my VR headset. Other people on tablets and phones and everything. So the number 2 thing that I had last year was inside-out position tracking. And I got a bit of a lecture last year after one of my in-the-hall conversations got picked up and turned into a bit of a news story where I was essentially saying, complaining. I'm saying we've got a few dozen smart computer vision researchers, and they're working on all this esoteric stuff instead of solving the inside-out position tracking problem like I wish they didn't spending the last year on. And maybe a little bit tact-free in that, but the basic, I stand by the basic position there, but it's a difference of perspective where if you come at this from saying that the future of VR is a PC-based system with static cameras, then the things that the vision team is focusing on, like eye tracking and face tracking and gesture recognition and room reconstruction, these are all great research topics, and they're going to be great features. But if you believe that the future is this portable mobile device that's going to require you to move around in the world, then doing any of those things first would be backwards, because you've got to have inside-out position tracking for your head before any of these other things really makes much sense. So I did have a little bit of a tirade about saying I think this is so important. This is the most important thing. It's got to happen, even if I have to do it myself. I worked hard on a bunch of stuff there. But the company did make the strategic decision that we did buy into standalone as an important direction for us. So now the experts are here, they're fully engaged, and they've got this. So I want to make crystal clear, because this gets picked up incorrectly in the press, that the standalone demos that we were showing over the course of the conference here, that is not my vision work. That's the work of the vision team there. Now, the demo got put together by a fairly epic crunch of people across the Dallas team doing all the Gear VR side of the works and the content side, and Menlo Park doing the new hardware bring up and all of this. So it was a big team effort there. But I know that it does get picked up. Everybody knows I was working on inside-out tracking. You could follow it through the lens of Twitter as I would go through various things. But the productization work that's being done now is by the core vision team, and I'm super happy with with how it's going. There's maybe a little irresponsible part of me that would have been happy if it was lone wolf programmer goes and solves most important problem for all of that, but no, it worked out. And we are being told a little bit, don't speak specifically about much of the vision stuff going on. This is like way out in the future. Don't draw too many conclusions from it. But I'm suspecting that the next thing that's going to play out similarly to this is about like hand and finger tracking, where we have a bunch of high-end research working on different ways with dedicated hardware and very specialized recognition algorithms. And we're in sort of this, this is not coming real soon. It's a little bit hard. We need to do different things. And maybe next year I'll be saying it's like, no, we'll do something simple with fingertip tracking and we can make a good user interface for this. And we have to go through a similar thing about waiting to get kind of company-wide buy-in. Because I do think that's the end goal for the billion users in VR is you have your simple thing and you do your basic touch interactions, and controllers are for the more dedicated experiences. And as all of our data is showing, at least half of the experiences that people are doing in VR are these more passive experiences. But definitely computer vision work. I had a ton of fun going through this, learning a lot. I'd love to sometimes give a really geeky lecture about all the details there, but it's a super important topic that's going to be shaping the world a lot in the coming years. So VR script was one of the other major things that I was talking about. We had identified this very real problem that's still with us today. Making VR apps is hard. We need to have some path to making it easier for people to do things where you don't need all of Unity or you don't want to fire up and become a native developer. So I had pushed this direction where I gave a live coding demo last year, and I was pretty happy with where we were going with this. I had this instant reload, very fast debugging, all sorts of interesting things there. But internally, we were going through some significant debates about what is the place of a scripting language in our ecosystem. As a company, what do we want to do with this? You're, of course, going to have some people that say, well, does this undercut our store? Are people going to be able to do scripted applications, and then there's no app revenue model? What does that mean as a company? And they're reasonable arguments to have. Obviously, I was saying that I thought this was really important, and eventually the company came around. We decided we do want to have some kind of easy-to-use scripting language. It's important. We'll be failing if we don't have this. So the next thing that was, or an action of that was, what the hell, John, Lisp? Are you serious? And I kind of knew that was coming, that the work that I was doing with Racket, which is a scheme or a Lisp dialect there, was not the broad, not likely to have broad acceptance. And the conventional wisdom, of course, is it's got to be JavaScript today, that if you're going to be doing something, it's got to be JavaScript. And I'm still not completely sure how I feel about that as received wisdom, but so Michael Antonov had done a version of VR script where it was set up in a nice way where we could plug in the language. It just communicated over pipes. So we had my Racket version, and he did a node-based version that let us use JavaScript for that. And we were making some progress with that, but it was at kind of a weird position where I wish I could have just dumped out what I had, even if only a fraction of the people were willing to use that, or maybe even learn a new language. I think it still would have had some value, but as we were meandering around on this, making some progress, there got to be a few important points about WebVR came out. Samsung announced that WebVR was working in their Samsung Internet browser. And that started a flurry of conversations internally where there's a huge draw to the power of being a standard. You want to say, well, WebVR is a blessed standard. Should we be using this so that people can work across multiple different platforms? There's got to be goodness in a standard. Now, to some people, that's almost a talisman. It's a standard. It's got to be good. And I try to evaluate things more objectively on the actual merits of it, saying that WebVR is a very, very, very tiny thing. It's just basically a way to direct WebGL rendering to head-mounted displays and then read some input tracking from it. And I always thought we should, of course, support this to the best of our ability. But the best of our ability on this is still going to be fairly limited. You're going to be limited to what you could do in a WebGL sort of framework. We can go ahead and ATW it, and we can get as low latency as possible, but you're still going to be limited to basically working inside this web stack. Now, some people can make a pretty impassioned argument that the web stack practically runs the world, that so many important things are built on the web stack, and it's not just like WebVR as one small tiny piece, and then WebGL, and then whatever things that you layer on top of that, 3JS or A-Frame or whatever, but it's the whole way that browsers work and the things that go on in browsers. And it's a powerful argument, and I am hesitant to do battle too fiercely with that argument. I do think that there is a lot of value there, but I'm still not bought in that should be the foundation for virtual reality. I think that it's important that we've got to have that, and we are getting some surprising lessons from the Samsung Internet browser is always right at the top of our apps list in terms of the time people spend in it. Now, obviously, it's largely used as a video playing app, but there are people doing actual web things in VR, even though it's not a great experience for it. There, especially at the beginning, it was not very good for text rendering, and it's not optimized for any of these things. But there is this clear pull for people to want to experience the web in different ways. So I think that we do need to do something with that. And for me, the killer argument for WebVR is that I don't care about portability across different devices. I think that it's fairly limited to say against different VR devices to say, well, you can run this on Gear and Rift and Vive. I think that's far, far less important than the idea that you can run this on a mobile phone or your PC browser. So an experience where you could be scrolling through your Facebook feed and you see an interactive WebGL system running right there that goes out to billions of people, that's a reason to construct some of that content that the fact that it can play in VR then becomes almost a bonus. I think that people are radically underestimating the difficulty of being cross-platform across like Gear to Rift. It's a 50x or so difference in absolute raw throughput. And if you're not taking advantage of any of the platform tricks, it really is just that big of a difference about how many pixels and vertexes you can draw. I've always said that there's not a Rift game or experience that I've seen that I don't think I could capture the essence of on a Gear VR class of hardware, but that's not easy, and that's coming from someone with a lot of domain-specific experience there. So I'm not super bullish on this grand world of we're going to have a ton of WebVR content running on a bunch of different things, but it's definitely going to be running. It's definitely going to be a platform that makes sense for a lot of companies to distribute content on, because they will be able to author things in a way that they can reach conventional viewers, and then VR is the bonus. Whether it's high-end VR for location-based entertainment type things for showing things off, or hopefully people getting limited enough content that runs on Gear VR. But it won't be taking advantage of all the kind of some of the neat things that were happening in VR script was like automatic use of layers, automatic use of background speculative panel loading, and some of these things, all the things that we were doing in our first-party applications. That's really not there in WebVR. Maybe we wind up extending it in various ways to that, but then you're not a standard, and then you have little if-def regions sort of written to the different things. That may be the world that we wind up in, but I worry that it is just this massive thing that we can't drive very nimbly, because it was interesting listening to the people working on it, where they would say, like, I thought UE4 was a large code base, but the Chromium code base is just a whole nother, probably literally order of magnitude about all of that, and just figuring out how to get the thing to build, let alone plumbing all of our special features into there, is a really big deal. So, but there's so much force behind the web ecosystem, and there's a saying in rocketry that given sufficient thrust, pigs fly just fine, and I'm very hesitant to bet strongly against JavaScript or a JavaScript ecosystem there. One of the other things that was a big deal last year was the first social applications that we had, where we had our social, Twitch and Vimeo streaming that had one-cut-it avatars and the first social interaction. And I was super excited, where we had a poll afterwards about like what people thought of the different things that they saw at Oculus Connect. And the social experience was right at the top. This was the thing that people thought was the most exciting thing that they were seeing there. So internally, we have one of the things that's been a travesty at Oculus, where I think we have had 5 different avatar development plans and strategies from the beginning of the company. We've got the Rift one out here today. We have Gear analogs of that being developed. We have the things you saw in the keynote that Zuck did. We have another team working on something like that. We had 2 earlier ones done by other people. So we have not had internal alignment about that. So the social stuff that got pushed out was unfortunately left to pretty much wither, where we put it out there were some people in it, but we watched the users, and it fell down very quickly. So you got to the point where, well, if there's 20 people in our social stuff, this is not exciting, or it looks like a direction that we want to work on. But of course, I'm like, well, we need to be doing things. We need to be out there finding what people are doing. This watch movies with strangers is always a weird thing. It's not this basic thing that you want, but it's the first step where we need to get out there and kind of figure out where we need to go. I mean, I'm frankly jealous of companies like Altspace and VTime that are out there, in the mix, building communities, learning what the users want to do. So, of course, in the end, we have the power of Facebook, and I think we're going to be just fine in social eventually. But I don't like eventually. I want us to not lose a tempo. Let's get things done sooner rather than later. So we have a number of different social things that are in play right now, where our platform team mostly focused on friends and like groups and matchmaking and things, sort of a conventional Steamworks game-based sort of approach to social. And I have been pushing more for a Facebook-oriented sort of social, and there's several efforts that we're doing. Like one of the directions that's still going on as a kind of an outgrowth of the social stuff from last year is this notion of arena-based social, where we want to be able to have not 8 users or something, but have it set up scalably so that we can have hundreds or thousands of users. And I think the idea for the first pitch talk on that is that we'll probably try to do like a John Carmack lecture or something and just see how many people we can pile in to see what we wind up hitting as the limits. But this is doing things like server-side mixing of the positional audio. The current social stuff does positional audio based on just the locations of the different people. Each stream's a separate one, and they're mixed with a very high-quality HRTF. The mass social stuff mixes everything on the server into an ambisonic mix, which is then presented to the client, so you can move around in that, so doesn't wind up having a scalability limit based on the number of users on the client, and it can go up to several thousand on the server. So that should be fairly interesting. Kind of the last hurrah of the old social stuff is Otoy is just launching an update of their Orbex media player that has a lot of really interesting things with shared user content, where we've been pushing for something like this for a long time. I've been saying that if you could just have a web browser that multiple people could interact and poke on, that's potentially a killer app all by itself. I keep saying that my example for social is watching my kids and their friends just huddled over a tablet, poking at it, watching YouTube videos or whatever. And I think making that really, really easy to do and work well is an exciting thing. So Otoy's got some things with some great content sponsors and people. There's interesting content that you can go in and poke at with the existing social structure, but that's also being set up for a coordinated launch and the way the platform is migrating. So every year I talk a lot about the different immersive medias and the different things that we can do as with photos, videos, and whatever. And I always have to push a little bit about back against this notion of sort of the VR snob, the people that that's not real VR, looking down their noses at the media playback. I mean, of course, we can take the pragmatic ground of saying, well, our not real VR has 10 times the users of your, quote, real VR, and just go with where users are actually demonstrating what they want to do. But I do want to make an old-timer analogy with some of that when Michael Abrash and I were doing some of the really early stuff with Quake, or even before that at Doom, there were people that had worked with real graphics, people that had Evans and Sutherland image generators or silicon graphics systems. And there was a very similar feel to this. People looking down, it's like, well, you can't call that 3D. It's not even really 3D. It's like 2.5D. And look at the aliasing, some things that I'll even say here. And and I feel the same sense of that, where it's not a question of whether it's real or not real. It's whether it delivers value for people. And clearly what we were doing back then, in the Doom and Quake days, it was terrible graphics by a standard of people that had these high-end, fully filtered image synthesizers. But it did deliver real value. And I think that's where we are with VR today, especially on Gear VR, where you look at it and there's a ton of things missing. But the real question is, can you deliver value with it? And I think we already are, but there's still a whole lot more that we can do, even on this exact same platform. So video's gotten one big bump where the domestic S7 and Note 7s can now do 4K 60 frames per second decode. And that's great. It's twice what it was before. It was 4K 30 frames per second. And this means that where we need the pixels stretched around for 360 panoramas, you can get twice the resolution. But the problem is, it's like it takes at least half again as much bit rate. Not quite twice as much bit rate to double it, but it costs a lot more bits. And we're already skimping on bit rate quite a bit when you look at the bit rate that you get from a Blu-ray. And that's for projection onto a 1080p screen sitting in front of you. And we're decoding 4K videos at lower bit rates, stretching it all the way around you with giant pixels out. So I'm not sure where that's going to end up. Are people going to be willing to download gigs of content to get a long form or even medium form 360 entertainment at 4K 60 frames per second encoding? Now, we've been doing the viewport dependent streaming with Facebook. And this is one of those things that for a lot of people, it works out just great. You look at that and it's up to a 4x quality improvement. Some people really notice that when you turn quickly, depending on your connection and the phase of the moon and whatever, you may have a fairly stale, blurry blue view that comes in that snaps back to a better one. I still think we've got a lot of room to improve that. We spent a lot of time on a custom protocol driving that and didn't get the success that I had hoped for with it. But I still think I'm not yet convinced that we're anywhere near kind of maxing out what we can do with that. For streaming, that seems to be the only hope. It has to be this very focused direction. And we've gone through a lot of changes from pyramids to offset cube maps. And there may still be different projections that wind up working out better. So I think I still have high hopes that we're going to get a doubling or tripling of quality or total appreciated quality, counting, turning around on that. And that ties into the video streaming as a service SDK stuff that's going to be coming up to allow people to push 6K by 3K equal-rex to the Facebook infrastructure, have them all transcoded to this, and use that inside your own native applications. But there's some other interesting directions, like the March Madness basketball application. Instead of going with full 360 degrees, it went with a 180 degree by 60 degree cylinder. And that allowed them to take the same 4K video and draw it onto this much reduced pixel area. So it got many times higher pixel fidelity for the same kind of 60 frames per second high quality motion. And I saw, like, one of the apps that I reviewed on Wednesday was taking good quality 180 degree hemispheres and similarly getting a factor of 2 pixel quality over doing a full 360. I think there's still very good opportunities for doing things like this. Someone made the, I thought, kind of insightful comment about the different ways that you use 3D media, where there's some things, like if you want to be in the Taj Mahal or the pyramids or something, everything's equally valuable. You look around, you appreciate all the different directions. But probably the majority of content that people would like to create does have some degree of focusing. And there's a lot of options that you've got here. It could be just a 180 degree camera, which then avoids the whole camera mess of how many cameras and what your stitching is and all of that. Or you could capture a full 360 and have lovely stuff sitting in your master file so you can re-render it out at different future platforms. But you might wind up using an offset cube map projection or something to give great quality for the people right in front of you, or the people today. So one thing that's a big negative that came up this year is the first year of, like with the Innovator Edition, I remember having a conversation with the Felix and Paul guys, and they were complaining about you would see a tiny little tick, like a dropped frame, about once a second. And I was impressed that they even noticed that. But the difference is that they master everything at 60 frames per second, but the phones are playing out at like 59.2 or 3. It's not even the 59.99 NTSC sort of thing. It's just phones are not exactly 60 frames per second. So what happens is it play the frames, and then it would drop a frame there. I had always been saying that we should really fix this because 60 frames per second content is what makes things feel really fluid and you're there, and especially for sports content, it's important. It's one of the things that makes it look better than a traditional video. So I finally sat down to at least go gather some real data recently, and I noticed some other things about some apps, just video having a lot of stutters. I wasn't sure whether it was our streaming stuff or or something more fundamental. But when I finally sat down and captured data logs really precisely about when the frame is on the screen, when it's being decoded, I expected to see a nice linear graph of it going up and having a little tick and then going up. But instead what I saw was, for half a second, nice and smooth expected, and then a huge mess for the other half of a second. And this was completely repeatable. It's most obvious in 60 frames per second video, but it's affecting everything, 30 and 24 frames per second as well. Like a really obvious place that you can see this in the recent Yellowstone video from Felix and Paul. There's a time-lapse shot of like clouds rushing by overhead. And you can watch anything in a 60 frames per second video going, it's going nice and smooth, smooth for half a second, then kind of juddery, and then smooth, and then juddery. Now, this is all a result of something that changed in the way the video decode frames were released. And Android actually made a lot of improvements for traditional video display, where in the old days, you would decode videos and just whatever frame is last decoded, it gets pitched to the compositor. And nowadays, you can have a specific release time assigned with each frame. So ideally, you get several frames ahead, you're decoding a lot of them, and you say, this frame is going to be released at this nanosecond time, this one at this nanosecond. So even if your app falls behind, something else happens, you may have many frames pushed ahead, the compositor will pick up the right one. We don't have the ability to do that right now in VR for a few reasons. One, Android doesn't let you get at different elements of the external image stack. I mentioned this to some people at Google, and it sounds like they might be adding this, and it seemed like a reasonable request to let GPU clients get at some of the same information that their privileged surface flinger does. But right now, you don't have that ability. But we can fake that by building a chain ourselves, basically copying it over and duplicating the work in our own queue. And I essentially had to do that same thing for Netflix last year because they had to, they were relying on it being queued well ahead and the audio would get out of sync. But we need to push this for essentially all of our videos. So we build a bunch of frames ahead and we will let them be released when they need to be. We can get halfway there with the existing frameworks, but this is one of the things that we're going to be revving our low-level VR API for, to allow this notion of lots of layers that have different time releases, so that if you want to, you could push 2 or 3 frames ahead. And this is where, with asynchronous time warp, if you're looking around on a static scene, it can make up for it largely as you move your head around. But if you have a video playing, the video will still skip its frame because it can't just figure out what it needs to change there. But if we have multiple frames queued ahead, it can pick the right one. So this turns out not to be trivial for a bunch of reasons, some of which, like, we have ways you can play back video. If it's side-loaded, it may be playing back directly. If it's a cube map, it always has to be copied over to another texture. If it's streamed, it goes through a different path. There's a bunch of stuff to work out. But I do expect in the coming months to have some significant improvements, most noticeable in 60 frames per second video, but it will help everything. With 360 photos, getting Facebook supporting them is, again, a huge, huge thing. I mean, there are probably more 360 photos generated since Facebook started accepting them than there were in 2 years prior, because now people have a real mainstream place to put the photos out. So Facebook embracing first 360 videos and then 360 photos is a really good deal. When I first looked at the ones coming in from the Facebook, like from Zuck's lead-in post for this, I looked at it and I thought there's something wrong with the quality of this. It was a city skyscape, so you have lots of the buildings with the windows, repeating patterns across all of it. And I could pretty clearly see that this was an aliased view of it was a nicely filtered view, but from aliased source, where I could tell from the windows and things that it was skipping along some of these pixels and rebuilding a new image that was then filtered nicely, but it was not right. Digging into that a little bit, it turns out that the Facebook ingestion is limited to 6K by 3K equirects. And the problem with that is that if you start with a bigger one, like this was probably a professional image that might have been at 20K by 10K or some very large value, it's completely up to the client that's uploading it, whether it's Facebook for Android, Facebook for iOS, or for the web. The client, each one can do a different thing on how it decimates down to 6K by 3K before pushing it up to the server for conversion to cube maps and all the different things there. So that's an important lesson. Anybody authoring images for Facebook right now, you should pre-filter all of your stuff down to 6K by 3K with a high-quality offline tool, and then send it to Facebook. And then beyond that, we were always converting them, I think we still are, always converting them to cube maps, which is this additional resampling step. But if you've got a 6K by 3K equirect and then you convert it to a 1536 by 1536 cube map, there's always a loss in quality when you're resampling. So what I'm hoping that we wind up doing, we have the ability to do this. I don't know if it's made it into the code base yet, but we should be able to directly render the equirects. If we know that we would be taking the highest res version and it's limited at 6K by 3K, we should just take that directly. One of the things that makes that possible now is we didn't have this a year ago, but we have direct time warp layer support for equirect images. There's trade-offs with that relative to the cube maps, but if you know that you set everything up correctly, it can be a good argument for it. One slightly new thing that's at the fringes of improved quality is that the best way, like all of our 360 photos, again, all the great stuff that you see in 360 photos, kind of the best quality stuff that we have on our platform right now, they're all 1536 square cube maps with MIP maps. And if you look really, like if you do MIP map visualization, the interesting thing about being in a cube is we pick the resolution so that the area that's pretty much right in front of you on a face is at natural resolution or slightly stretched up. But because of the way the lenses work, you lose resolution as you're going over to the edges. So unlike a normal 2D view, you draw something on the screen, it's the same resolution across the entire thing. Presenting a flat image in VR, you get less resolution at the edges, so it filters down into MIP maps. Basically, it goes down to the first MIP map around the edges, and if you look straight down the corner of a cube map, then you are touching parts of the second MIP map below that. Now, trilinear filtering does a pretty good job. I recommend everyone enable that. That's one of the first things I say in my app critiques is if I see something first that has no MIP maps at all, that should basically be an app rejection at this point. But I still do see things where it's a more subtle thing where if you've got it on linear MIP map nearest rather than linear MIP map linear, you can see kind of a line crawling as it changes between the levels. But trilinear smooths all that out. But it's still not perfect. I mean, I do kind of keep elbowing some of the GPU vendors about it. It would be nice to have a better filter that doesn't wind up blending between a blurred image, a too blurred image, and a too aliased image. Blending between them gets you close, but there's still hints of aliasing, and it's not quite as sharp as it could be. Something that I tried recently that turns out to be of general applicability is not using MIP maps, but pre-filtering the images. So if you know that a given part, say right in front of you on the cube map, that's going to be fine. That's always going to be fine, wherever you need to look at it. But the edges there needs to have a broader filter kernel across it. So you can take an image, if you display it without any MIP maps at all, when you look at the corners or the edges in different places, they'll alias, and you'll wind up getting some of the sparkles there. But you can go ahead and pre-filter the single image and then have no MIP maps and get a higher quality. So you can be a little bit better than the bilinear quality. You can do things like make a 2K by 2K cube map, which will be slower, but because you don't need MIP maps, it wins some of it back. Pre-filter all of this properly, and that's a small step up over our previous best. So that's our current gold standard for the best that you can do in sort of static imagery. And you can apply that also to equirects, where equirects have if you've ever looked at one of them, they've got the problem of at the poles, they've got what should be 1 pixel stretched across 4,000 pixels. And depending on how that was generated, if it all came from stitching low-res cameras, it's all frequency bounded anyways, and it doesn't really matter. But if it came from a very high-quality, high-res equirect, or if it came from ray tracing something, then you have high-frequency data up there that you can't represent. And you could have something that looks great at the equator, but look at the poles, and you've got kind of a fizzling aliased mess. But you can pre-filter all of that out. So that's kind of masterclass level quality stuff where it's not that important relative to the other things, but it is a tiny step up in quality over what we've demonstrated so far. With 360 photos, we did a lot of work on doing progressive JPEG loading that in hindsight, I think probably wasn't worth all of the effort. It's surprising that it turns out to be in progressive mode. You spend a surprisingly large fraction of the total image just loading the basic components to be able to present the image up. And it's probably a better idea for anybody doing large-scale 360 image viewing, just having explicit thumbnails. And I know many other companies already do that, and that's probably the right thing to do now. Progressive JPEG, not really worth it. And I would go, when I take a low-res image, to do the nice thing that everybody's expecting now about not just the tinted bilinear stretch up, but do a nice Gaussian blur, so you've got a blurred image before the next one comes in. I'd still like to use H.265 for still images, get better quality for a given bit rate, but there's still licensing questions about that. Audio, it's great to see the ambisonic stuff going into our SDK. I think that this is something that we should have just like the equivalent of clip art, but clip audio for the different scenes, and every VR thing should be having something going in there, at least if you've detected people have headphones on. It's perhaps arguable that if people don't have headphones on, you don't want to add just extra noise there, but if you do have headphones, it's a good thing to add there. Voice is still underutilized in VR apps. It's one of the best things in terms of adding quality. Voice, in terms of media, is relatively cheap. You can get professional voice actors for not all that terribly much money. The question that comes up with that, though, is localization, where you probably can't get 17 professional voice actors for, appropriately for your title. And that's the question of, is it better to have voice in one language or maybe a couple languages and letting the others have subtitles? I would argue that it is, because especially for gaming entertainment, the shape of the successes in gaming it's a sad thing in some ways, where it's like this across all gaming industries. But like, I look at our sales charts and things for Gear VR, and we have, the top 10's doing great, the top 20 or 30 are doing pretty well, but it falls off for the bottom 200 are not doing very well, and this is the nature of gaming across all platforms. It is a hit-driven business. So sometimes modest improvements in quality relative to other applications can be significant. It's kind of like the dogfighting analysis, where you don't have to be a lot better, you just have to be a little bit better. And I would argue in many cases that you never want to not do something that makes it better because it's not available everywhere. So I would suggest use voice as much as possible, even if it does mean that maybe it's not as good for the rest of your markets, but pick the ones that you care about, and that's still a relatively cheap way to add useful things. The big announcement for this show, of course, was working on standalone. We got to give some demos for a bunch of people, but we really can't say too much about it. It's exciting in a lot of ways. On the technology side of things, one of the most exciting things is being able to have total control, not having to be sharing it with a phone, where we have a good, our working relationship with Samsung has allowed us to do, I think, a really magical thing with Gear VR. But there's no question about Samsung is worried about selling all of these phones, and VR is important and useful here, but in terms of what happens in the software stack and what's running, as it should be, it's totally dominated and driven by the phone use case. And that does mean that even once it gets past Samsung, then there's whatever stuff the carriers throw on it that even Samsung can't control what they do. And I've had many sad times when I'm looking at performance optimizing something, I get a systrace, and I see this wall of activity going on, and I'm hunting down going, where is the actual app that I'm tracing? Because there's all of this other stuff going on in the background. And this is causing us thermal problems. This is some of the stuff that drives us crazy, where we can have a developer that says, I can play my game for an hour and a half. Why are people getting these thermal overheats? And some of it's climate, people in just warmer places, but some of it's also the other things that they've got running on their phone. So it is super exciting to have the idea of having total control over it. And if we can make mobile-based hardware much closer to the way you can develop for a console, there is a large factor of quality improvement that we can get from that. I've always said that consoles can deliver twice the performance for the same amount of raw processing power, just because people know what they're aiming for. And when you know what you're aiming for and you can use all the facilities there and you can tune it specifically for that, that's a big win. Right now, rightly so, many developers just say, this is a mess, it's different on the different platforms, I don't know what to do, it doesn't make that much difference as I'm tuning it because different things are running. But if we are able to get to this where there's nothing running on it that doesn't directly impact your VR experience, that's going to be great. To be able to look at a log and not see crazy things going by that you have no idea what they even are, but to see the log just talking about things that actually matter to VR. The thing I've been kind of nudging Samsung about for a long time, my sneaky plan to try to do that on the phone is if we could just push everything that's not VR related, not kill it, but push it onto one little core and run it at 300 megahertz and let it just kind of sit there and fight over the crumbs and leave the main cores for us. That would be a good thing. I still think that's feasible if that requires kind of fighting at the larger scheduling levels of things, but I have some hope that we could get to that point eventually. And the big thing, the engineering side of things with standalone, is this possibility of really being able to throw more, literally, power through it, more electricity through the core to be able to get more power out of it. Because as developers on Gear VR, we can't even use 1/3 of the actual power that's there. We have our GPUs maybe at half the peak clock rate, but the CPUs are often at half, but we can't do like all the different video encoding things and Wi-Fi and GPS all at the same time. I heard an interesting statistic recently where the hardware vendors have something they call a power test virus, which is something that tries to blow all of the power possible into one of these just to make sure nothing shorts out, or that the thermal management actually takes care of it. And I had always been thinking, because I've done similar things like when we were trying to do asynchronous time warp on CPU cores, and it was easy to get like 60 seconds, have the phone overheat. But I was hardly trying. That was just run the CPUs there. What if you run all the CPUs, all the GPU, max Wi-Fi, max SDI, max static memory read, all this stuff, throw everything at it, and apparently it can get up to like 25 watts draw instead of the normal maybe 3 watts or something. So this has to be a case where the hardware has to very quickly trip that, or stuff will just fry. But with good thermal management, you should be able to, like, if you've got all that power available, if we can pull all of it out with thermal management, then we should be able to make things that are a couple times better than what you wind up getting on similar mobile hardware. So that's pretty exciting, but there's unexpected challenges for that, where PC builders are used to slap a big heatsink on it, put a fan on it, liquid cooling, whatever, and you can draw hundreds of watts out of high-end PC hardware. The CPU core the surface can get really hot, you can pull lots of power out of it. But in mobile, you've got the problems that a lot of these are stacked dies, where you have, you've got your CPU cooking away there, but then you've got memory literally stacked on top of it, and then it's in a plastic case. So these are all terrible for thermal dissipation. So there's interesting questions about, nobody's trying right now to run those chips as hot as we would like to run them. So there's going to be exciting things as we kind of figure out the engineering there. There's other things that we can choose to take advantage of, like the Qualcomm chips they've got DSPs as well as CPUs and GPUs, and Qualcomm talks about kind of their three-pronged strategy of, you don't want to think about just CPU, GPU split, but also DSPs. So some things can go there, and that's a reasonable way to do things. Other vendors are starting to add similar DSPs. You can hijack if you're not on a cellular network, you can hijack resources that are normally used for your baseband processing and also use those efficiently for some other things. And maybe if we've got our own system, we can get in some of my pet ideas, like the demand page GPU memory, being able to just memory map a bunch of flash and have it come in as necessary. That I'm unlikely to get that into Android directly, but maybe I can get somebody to try that out on our own hardware, which would be really exciting. So the core issue here, though, is that we need to build better apps. I mean, there's no kind of better way of saying that, is that our applications, we're not held to a very high standard right now because VR is brand new. People aren't putting in that much effort to it. Everybody knows what a AAA game looks like with hundreds and hundreds of man-years of effort put into it. And we know that the small teams that are building small VR apps, you don't expect it to kind of have that level of professionalism. And the same thing with apps. A lot of people think that, oh, apps are easy. There's all these, like how to make an application in a weekend or something. But making a good application is still a very hard thing. There's so much work that goes into UI and user testing and all the things that really make the difference between an also-ran and the thing that leads the category. So stepping up, really bringing us to the next level on our applications is the key to getting VR to really take off, where we are coasting on novelty and the kind of initial wonder of something that people have never seen before. But we need to start judging ourselves not on a curve, but on an absolute sense. When you look at an application here, yeah, there's no way you're going to have the same effort put into it, but can you do something with VR that makes it have the same value or more value than what these other things have done? So we need to be harder on ourselves. We need to judge ourselves harder, make sure that the things that we're doing really do stand up and deliver value. There's the joy and wonder is important, even in applications. Like games are a lot about just the sense of wonder. You might have a disposable experience that you go in and you say, that was a great half hour or an hour of time I played. I'm happy with that. It was worth my money. But we need applications that are going to keep people coming back week after week. We want our weekly active users where people come back and every week. So Minecraft is my weekly active VR application. We need many, many more applications that cover other people's wants and needs that make them come back every week and use it. So I did 6 hours of formal app reviews on Wednesday, and many more impromptu ones in the halls afterwards. And there's a kernel of value and goodness in almost everything that I'd see, but I had comments, specific comments about almost everything there. By the way, the format was obviously not spectator friendly. We weren't thinking this too much through, where I thought this was just going to be my normal hallway conversations just in a room, just so that we're a little bit insulated from the noise and whatever. But it turned into a thing with a queue of applications coming in to do this, and it was horribly boring for people seeing me with a headset, turning around, talking about something nobody else can see. That's an excellent goad to make us get a easy-to-use, overhead-free streaming system going for next year. And for those of you that have fought through that, you've got things like there's a version of Chromecast that would work that gets it to a separate TV, but then it winds up glitching up the view inside there. And in hindsight, I could have gutted through that. I'm not that sensitive to some of the disturbances, and mostly I wasn't talking about exactly the performance frameworks, the performance metrics that I was looking at. It was more other things, so I probably should have done that. But we do have work going on right now for setting up live streaming, doing our video encoding, like pushing it to Facebook. So productizing that in a way that it's so easy to let anybody do that. And this is where an important part about features is it's easy to imagine this being some fairly painful thing where you go into universal menu and you gaze type something in going to get it up there. And we want this is going to be an excellent use for it, where I'm going to say next year I'm going to do the same thing, and it needs to be so easy for this to happen that everybody that's walking up with their phone can say, okay, I've got it live streaming and it's going to be showing up on that monitor there that everyone can see. That's actually a fairly big challenge to make things that simple. The technology of just making it work. We've got the video encoding, we can pipe it to different things, but this is the difference between that first glance of a feature existing and making the feature a killer feature. And that's not going to be easy, and it would be easy to punt quickly and say, I've demonstrated proof of concept, now we need to kind of take it to this productizable level. And honestly, I often get to do exactly that because of my position. I feel guilty about it sometimes. That's how our video recording went. It's like, okay, I made a proof of concept, I've got a video out here. Now, someone else, James Dole in this case, went and actually turned it into a feature that handled permissions and doing all the other things there. But that's a theme across all of this, where that initial bit of magic, to be responsible, we have to take it past that. We need to go ahead and turn it into an actual really good feature. So I am unabashedly advocating for Gear VR. I feel that I need to, because the alternatives are everybody loves working on Touch and Rift, and it's magical and easier. It's still not easy to make a Gear VR app, but when you can throw 300 watts of TDP at it, it's sure a lot easier. But I come up here and I say, the future is mobile. I think that as we look towards 1 billion people, that it's not going to be on PCs for this. There are maybe 100 million PCs that can do VR in various ways. But I believe in the mission and how Facebook bought into Oculus about there will be a time with 1 billion people using VR. And as it approaches that, it's not going to be this higher and higher bar of power that you're getting to. It's going to be a lower and lower bar of adoption, where we started saying that a Note 4 defined the minimum bar for what I thought reasonable VR would be. There was broad debate about that. Many people thought, no, Rift defines the bar, the minimum bar for what acceptable, useful VR is. I think that we're going to find that that sort of Note 4 level of power really does define the minimum bar, and we go down to cheaper and cheaper headsets, cheaper standalone solutions. Instead of having $50 phones, you have $50 phones that can eventually become VR devices. So this level of performance I don't think is going away. Things get a little bit easier, but it's going to stay hard. And I think that that's where the real value, where you can impact the most people are. And it is like a puzzle, and I know different people have different views on this. I love the challenge of kind of working in the smaller box, finding the value, making the hard decisions, because it focuses you. It makes you really decide if you can only do a subset of these things, you'd better pick the right subset, the one that's the most value to your users. I love this micro-optimizing approach, but lots of people don't. Lots of people just want to be, it's like, I have my vision, and I want my vision made real in the easiest possible way, with kind of the least effort so that I can do more things. On the PC, I think that the PC is going to be like the creative class. It's the laboratory for things where it is amazing what we can see and all the different things people are trying out, but we mine all of that and figure out what do we want to try then pushing out to the millions of people that are on the lower end systems. And it is a matter of you can approach all of these things. Again, I think anything people have done on the Rift in terms of a presentation, the essence could still come through on a lower-end system. We are used to, especially as game developers in the modern age, doing all of these incredibly sophisticated things that honestly have fairly limited payoff. I mean, I commented many years ago that we crested the knee of the curve in terms of cost benefit for what you get. We're still climbing in terms of making more valuable things, but we are you don't get the extra bang for the buck of twice the power that you used to. I mean, it used to be when you're climbing the hill, doubling the power gets you a whole bunch more stuff. But we've crested that knee, and doubling the power that we push into something gets us slightly better looking things. And there are whole sets of techniques and people. It's like find old timers that anybody that worked on an Xbox, an original Xbox or a GameCube or something like that, and tell them that, well, our minimum clock frequency is 800 megahertz or something. 800 megahertz? It's a lot of power that we've got on the phones, but people are so used to having multiple gigahertz and incredible GPUs. But it's absolutely possible to do great things with that. It's still a little bit different in that while we have lots more pixels that we need to draw, it's like 120 megapixels per second or something is what you need to do Gear VR quality 60 frames per second stereo, which is a big difference from the 10 megapixels or so that you would have rendering to an NTSC TV in the old days. But you still think the same basic things. You don't use crazy techniques. You're not using subsurface scattering. You're not doing multiple layer order independent transparency, different things like that. But I know it's hard. Jason Rubin made a comment that the developers that have tried to work on Gear VR coming from the PC, it feels like they lost a level, where they feel bad because they feel like they're less than they were before. It's like the AAA developers became indie developers, the indies became hobbyists, and the hobbyists failed. And it's just harder. It's true. So I hope to inspire some people to buckle down, learn the right techniques, learn what you need to do differently to actually make that happen so that we can get richer sets of content on this. There are plenty of people out there that I think should be recruited into the VR space that have been there and done that on systems from 10, 15 years ago and have skills that are transferable to the optimization here. But largely it's a design challenge where you want your design to be in sync with what the hardware does rather than bullying your design through sort of against its will. And that's why I do think it's important to start knowing the capabilities of the system that you're going to be deploying on. Rift as a development tool for Gear VR makes a ton of sense. The development cycle on the Android phones is really not good. I spoke to several people that are setting up labs for students to learn VR development, and my advice there is you definitely want to be using high-end Rift PCs just so that it's not ridiculously hard to get that first satisfaction of making something work. But eventually you have to figure out which changes you make in your limitations. Like as an artist, I like to think that a good artist can go ahead and make something great with just about any medium. You see sometimes magical things that artists can do with just a few lines to convey a composition of something. But there's a lot of kind of pushback sometimes to giving up favored tools. And you have to make sense, like you don't want to make an etching with chalk. You just have to do the right thing with the tools that you've got. You can't change the tools right now of the hardware, so that means your design has to change. You don't make it in a vacuum. So the Oculus Rex team in Seattle, composed of world-class content creators, they did some work on Gear VR recently for the Prologue project, and I heard there were some grumblings at some point about working on stupid puny cell phone, whatever, but they did some beautiful work with it. And I have that confidence that artists that are made aware of the limitations and can understand it, and it's an understandable process. And unfortunately, sometimes it's not, where what's making it slow. Is it my texture, my vertexes, my resolution that I've set it up at? So I would say that's the best plan going forward, is the more knowledge that we can make visible to people, the better. Now there are objective measurements of quality. Design is an abstract thing, and there's, we can argue about some design things about, it's like arguing about humor, whether something's funny or not. There are some things which are not objective, which are going to be subjective to the individual user. But there are some things about application quality that absolutely are objective. Load time is one of them, where I'm always happy to see in the mobile space where they have like app races about how fast each phone, phones can load and reload different applications. I think these are valuable things that the game industry, in contrast, generally has. Like on consoles, you'll have a TCR where you can't spend more than 30 seconds or so loading, and most teams are fighting and struggling until they can get down to 29 seconds and call it a day. And that's acceptable in a situation where you're going to sit down and you're going to play for an hour. Then if it took you a half minute for every level transition, that's probably not bad. Maybe you've even built that into the tempo of your pacing of your game. So you amp everything up and they're almost happy to have a little bit of loading time. But initial startup time really is poisonous. An analogy I like to say is, imagine if your phone took 30 seconds to unlock every time you wanted to use it. You would use things a lot less. And we're at that situation with Gear VR right now, where even aside from the pulling your phone out, maybe taking a case off, docking it in, getting it settled on your head, it can be 20 seconds till you can interact with home. This is not a great thing. And then launching out of that to the application you actually want is even worse. And then that can take potentially, there are apps that I wanted to play that I thought looked great that I stopped playing because they had too long of a load time. I would say 20 seconds should be an absolute limit on things. And even that, I'm pushing people for much, much lower. One of the things that I've been happy to be able to talk about with a term now, the show Halt and Catch Fire had a little bit in it about the Doherty threshold, which was they were trying to make it dramatic about getting below 400 milliseconds response time there. And there really was a paper published by an IBM research scientist talking about the importance in productivity of bringing actions down from a 2-second time down to 400 milliseconds or so. And it's great to be able to point people at that rather than just saying, efficiency, making it happen fast is really important. So I would like to see this in VR apps. There's some things that we've built, like there were some VR script applications and some of the new VR shell stuff I hope to get to talk to at the end, where you could be jumping between things super, super fast. And it's an unexpectedly pleasant experience to be able to be jumping into things in a half a second or so, to have something just jump in and it's your wish is my command. That's what we want out of our computing devices. We want them to be the genies that are instantly satisfying our wants and desires, not that we have to step-by-step command them through different things. That wraps up a whole bunch of different user interface aspects, but the ideal is once you've decided what you want to do, you want it to happen fast. You do not want to wait around. And in some ways, it's worse in VR because what people do for long loading times in the real world for things, you might pull out your phone, switch over to Facebook or something while you're waiting for your game to load to the next level. In VR, you're stuck there looking at, worst case, a black screen. In the simple case, everybody should be trying to just put up an asynchronous time warp, single panel, fade to black at the edge, draw it once, don't be running a scene, don't be trying to do anything clever. I see efforts for people to do animated load screens, doing shines around things, actually changing the scene. There's a number of reasons not to do that. One is that on a technical level, because of the way it works, if you happen to be looking aside and it's choppy frame rate not updating very often, you can catch it with your scene at the edge of the screen. Then when you look back over there, ATW may be pulling it in over here, but you've got everything sheared off at a black line because you spent a half second without updating the scene. But more importantly than that, just with almost anything that we choose to optimize with a number, it is so much better to actually make the number smaller rather than to hide the effect of this. And I point to a lot of the research work that went into like predicting head positions for virtual reality, where kind of pre-Rift era, there's lots of papers going about what sophisticated model of how the human head and neck moves do we use to try to predict 50 or 100 milliseconds into the future. And that's just wrong-headed work. What you want to do is get the actual latency down to a much lower value. So similarly with load times, the real priority should be don't take so long to load. Don't do multiple kind of clever things to cover it up. There's a whole set of techniques which are common knowledge in some circles about the way that you manage expectations. Disney is a master of this at the theme parks, where they have all the cues going through here. They go through different areas. They change what you're looking at. They try to not make it. If you were just in the back and forth metal turnstiles the entire time, it would be a much worse experience. But it would be so much better if you were just fast passing to the front on every single time that you went there. So applications should be like that as well. Microsoft did that in like Windows boot up times when computers were slower. You'd start on the BIOS screen, then it would go to one Windows logo, then to something else animating, and then finally it would get to like a login screen while it's still churning around in the background. But again, it's better to just like not require the resources that make it load so slow. So in terms of what's possible here, it's always useful to figure out what the speed of light is and then figure out how far away you are from it. So I did some timings on some of the phones and how fast can you load things. And I was measuring 300 megabytes per second reads from flash. Texture uploads, depending on the system, 150 to 200 megabytes per second. So most of the time when I see an application that's, that's taking 10, 20 seconds, 30 seconds to start up, I can load up like Snapdragon Profiler or something and see all the textures that are in there. And it's not like they're loading up 2 gigabytes of textures. There's other reasons why things get slow. One of the biggest a discussion that we're having back and forth some with some of the Unity folks is that I would argue that the simplest, straightforward way that's least likely to get messed up with this is you just memory map files that aren't compressed and you text sub-image directly from there. But a lot of game engines are set up with multi-thread pipeline decompression schemes, which in theory, as long as you've got the clock rate up, you can be like LZW decompressing something at a faster rate in theory than you can read it from Flash. I agree on some systems. I'd be a little dubious at exceeding that on the 300 megabyte per second read range, and I'm agitating a little bit for you should have some option to be able to have your textures set up in this memory mappable format where it just goes in, starts up, memory map everything, upload, 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 deallocate it. So there's definitely some possibilities there. Everybody should be using for almost everything compressed textures. In a native format, we use the KTX format, but just ensuring that their ASTC compressed is really important. I still come across big textures that are 32-bit RGBA that is costing you load time, power draw, thermal issues, and frame rate. It's across the whole board where the great thing about ASTC, its adaptive scalable texture compression, is unlike a lot of artists may have had bad experiences with DXT texture compression, where it was this fixed thing, it goes down to 4 bits per pixel, and sometimes it makes your beautiful art look like crap. It comes in and you could see these big blocky forms, or you've got colors lost because it only had 2 endpoints. ASTC is much, much better at at everything. If you pick the same 4 bits, it's still a whole lot better. But the neat thing is it's scalable. They have everything from 8 bits per pixel down to like 1.5 bits per pixel or something, and you can switch between it. Another thing that I was really happy to see, the Oculus Rex team on Prolog, I'm looking through it with Snapdragon Profiler, seeing what all the textures are there. And it was the first time I had ever seen somebody actually using variable ASTC things. They would go and say, this one's at 8 bits per pixel, this one's at 4, this one's at 2. And it worked out really well because walking through the beta process on that application, we saw this great looking stuff, but we could point out, okay, I can see like a gradient here or a blocking artifact here. And at some point they went, it's like, well, that's going to get a little bit more bits and it's going to get fixed up. Most people won't be going through that one at a time texture kind of analysis question there. But if nothing else, never send something up that's static as RGBA 32. Go to at least the 8-bit KTX. Every Gear VR, back to the original Note 4, supports those formats, and you absolutely should be using them. The next thing that can kill you is shader compilation. Like we had a killer case in Time Warp, where when we went to our flexible layer system, we had many more possibilities that could be combined into the shaders that you could use there, because at one point we started compiling all of them, and we had this point where it was taking 5 seconds to start up our simple native apps just to get going. What the heck is happening? And it was because we built a couple hundred shaders at that point. We went to dynamically doing it, and this is something that old-timers will have a bit of a knee-jerk reaction about dynamically moving, doing a shader compilation. That's going to add a hitch in your frame rate sometime. There are reasons to avoid that for general purpose things, but because a lot of these things happen at understandable positions, sometimes at scene transitions when you go to something different, it really is good to defer creation of some of those things there. Like if you've got something that's multiplayer or social based, and you know that a bunch of people are going to be starting up in single player, don't create those resources at the beginning. Wait till it's actually needed. So Android does cache binaries for you automatically, so there's no real benefit to using like the binary shader extensions, shader caching extensions. And then one of the really big things that that came out is because we limit the clock rates, we let you pick which CPU level you're at. Generally, for better battery life and thermals, people choose as low of a CPU level as possible. That's the right thing to do during your applications. But it does mean that any loading that's going on is happening at that very low clock rate, which you might be at a third or less of the peak clock rate, and that could make your load times 3 times as long in some cases if you're totally bound by CPU rather than I/O. In all of our native code, we've got it set up now so that you start up and the clocks are unlocked. It's just like a normal Android system until you render your first frame. Unity, I think, is set up like this now through the initial load, but I don't believe we've got that yet for in-game transitions, like when you load new data sets. So that's one of the really big wins that we should be able to get out and make more general. But that's yet another reason why you should not do fancy loading scenes, like going to a scene that's doing things. We want to use the built-in transitions as much as possible so we can automatically fix some of those things up for you. Yeah, and switching. Another thing that I'm hoping to get as we move towards some new application paradigms and standalone and things like that is right now we are one VR application at a time. We let home kind of live on, but we want applications to eventually get wise enough to be able to act like normal Android applications, of letting them go into a pause state, letting them come back. So we will get to a world where people are switching between VR apps just like they switch between apps normally. It's not clear if it's exactly time for doing that yet, but it's getting close. As an example of how things go badly, Cinema started off as a very fast-loading application in the very early days, but we added more and more things to it, especially these large theaters. You know, the theaters are 40 or 50 megabytes each. And at the start, we were just loading all the theaters all the time, and it got slower and slower. We had our native app that was taking a really long time to load. So it was clear it needed to move to defer those loads. Most people are not going to be switching through multiple theaters each time they go into the theater application. You should obviously just wait till they even get in there. They might not need a theater at all because you could go into the lobby and then pick a 360 video and then quit back out without ever going into the theater. Or even more so, you could be launched from another application with an intent and load a 360 video and never even see the lobby video. So deferred loading is a really important thing there. There's the puzzle solving part of my brain starts thinking about what is the speed of light case for a lot of these things, where it turns out it winds up being sort of a dependency graph of sometimes you have to establish a network connection, figure out you need to do something, then maybe you could spread out a lot of threads to do multiple resource loading or shader creation at different times, wait till you get a DNS resolve coming back and do different things. And it's in the limit, it's an interesting problem, but just following sort of the 3 key things will get you a long ways. Now, Android does some exciting things to make applications load fast, where I had a point a few months ago where I was launching standalone Android applications where not part of the normal Android ecosystem, just run as an EEX from ADB. And I noticed that OpenGL was taking like almost a second just to initialize EGL. I'm like, that's, normal applications start up much, much faster than that. I asked someone at Google, is there any Zygote magic going on with this? And he was, yes, indeed. There's the thing that Android does that's pretty clever is all of the systems kind of spawn off from a Zygote process that links in, pre-links all of the libraries that they might need and does a bunch of setup, including some of this OpenGL stuff. So Android's paid a lot of attention to things like smooth frame playback, application startup, and these are things that anything that's important to 2D is probably going to be important in 3D as well. So frame rate performance is what most people think about in terms of optimization. And the Unity people tend to over-index a little bit on draw calls because when all you've got's a hammer or all you're aware of, then everything looks like a nail. And draw calls are the thing that everybody calls out as like, this is what's going to kill your performance. But often it's not. There's a lot of other things that can be killing you. Too many draw calls definitely will kill you, but we've seen too many cases of people that have completely reasonable draw calls and still have poor performance. Now, multi-view is going to be the thing that helps the most for draw calls, where it essentially cuts in half the cost of the draw calls. And this is one of the failures of the Android ecosystem where we're at right now, where it's been over 2 years since we started talking about multi-view and we started getting extensions for this, and we still cannot deploy it universally across our applications. It does work on the Exynos chipset ones right now, but it still is not enabled on the Qualcomm chipsets because there's a bug that basically doesn't let it work the way it needs to for this. And Qualcomm's fixed it a long time ago, but it needs to get into Samsung. Samsung needs to get into an MR. It needs to get out. Carriers need to pick it up. And this is terrible. I think the S7 still hasn't gotten most of the things that we know are fixed that are causing performance problems there to get rolled out. This is a pretty fundamental problem. And it's the same, it's related to the way things were on the PC 18 years ago or so, when you had all of these companies getting chipsets, and many of them, they would tweak the drivers to cheat on a benchmark in various ways, and they would have their own version of it. And it was terrible. You had, even if they were just NVIDIA and AMD parts, they had custom drivers on different systems, and they didn't get updated, and it was so problematic. The world is clearly a better place with NVIDIA and AMD doing direct-to-consumer driver updates. For all the problems that there are with over-aggressive optimizations and various things, it does mean that you have a hope of discovering a bug and actually getting it fixed. You know, we are in cases where bug is discovered and years can go by before it actually gets rolled out. Because most of the time you need to do this iteration. You say, okay, here's a new extension. You need to actually try to use it. Ideally, you need to try to use it 3 times in 3 applications to have any confidence that it's actually working. And when you find bugs, as happens most of the time, it needs to go back to the hardware vendor and they need to get a fix. But it's almost here. So multi-view is going to help a lot. It's going to basically halve the cost of the draw calls, which will save a lot of CPU. I hope that everybody doesn't go out and just throw in twice as many objects for things, because we want this to actually be a savings on our thermals and, and frame rate drops and all the various things there. But the big win's going to be when Unity and Unreal have support for it. They're working on it. I don't have an ETA for it. I'm hoping that it's going to be not too far away, because a lot of apps will benefit a lot from this. We see in our native apps like Cinema it's basically nothing but a lot of GL draw calls. So we saw in one case literally a 50% decrease in CPU, because there's not much going on. The video's playing, your head's moving around, there's hardly any computation. All we're doing is 80 draw calls or something. So putting in multi-view, it cut that in half. Now that only turned into maybe a 10% or so power advantage in terms of how long you can play or the thermals, but it still helps. The biggest thing that you can do for getting good performance, and it also improves the quality on Gear VR, is building your application around pre-lighting, where instead of, definitely avoid things like specular bump maps, a lot of dynamic lights, things like that. These are things that it's a triumph that in the high-end world we can do this, and you can build games that are built around this and require it, but it is so the wrong thing to do on Gear VR. If you're willing to pre-light things, the thing that we have in abundance is texture memory. You can use a gig of texture memory. I mean, I don't recommend going that high just because load times and download times and all that. But these phones, you can have a gig of compressed texture memory, which is an enormous amount of textures that are shown at very high quality. So you have the opportunity in most VR applications. Most of them are not free roaming. Most of them are limited to a few specific areas. I still want more free roaming games. I think there's a lot of magic to be had there. But when you've got a few specific points, you can pre-render that scene at extremely high quality. Again, Otoy has some examples of baking high-quality lighting onto relatively low-fidelity meshes. Every artist has their own sort of pipeline for doing this. Like if you look at our cinema scenes, were all done like this, where you build something high-quality, use whatever tool the artist is comfortable with to lay out the textures and generate the lighting there. This has multiple benefits where it looks great with the high-quality lighting. It also, importantly, filters extremely well. Anything that you're doing a calculation on the pixel that's not completely linear, you get those subtle things as you move your head around, things sparkle and weave around a little bit because the changes are not exactly summed up by the bilinear filtering. If you pre-light everything, it's going to look great all the time. That's one of the most important things you can do. It takes an artist that knows the tool chain, the way to do that. It does make re-rendering and changing sometimes less flexible. You do your layouts and experimental testing before you spend all the time to do it, because sometimes these bakes may take days to do, depending on the hardware you throw it to, but they really do look great. And again, compressed textures wind up being an important thing. One of the things that's been a little bit surprising to some people is in many cases, when you're using compressed textures, you wind up not spending much time in the fragment shaders. It is not uncommon to see vertex shading becoming a bottleneck on these systems, and sometimes for reasons that seem a little unexpected, because vertexes may need to be shaded more than once because of the binning or tiling nature. So sometimes you see vertexes. I'm looking at some pixels, and the cost in vertexes is more bandwidth than the cost in shading the fragments. One of the things that it looks like almost nobody is doing right now, it doesn't seem to be the standard Unity options, but compressing the data that's going to the vertexes. Instead of just saying everything's a float. Texture coordinates are float, vertexes are float, normals are floats. Most people that work on consoles are very familiar with, all right, we're going to put these down to unsigned bytes. This will be a half float. We'll add a scale in the vertex shader as necessary for this. And there's some good performance to be had there. Vulkan will be an even bigger performance improvement than Multiview. It's one of those things that we were, again, fairly pleasantly surprised to see. Multiview, in straightforward cases, doubled our performance. In some cases, Vulkan could double it again. Vulkan is definitely a mess to work with. We don't have all the things worked out to be able to use it in VR yet, but that's coming fairly soon. But again, it'll be gated on Unity and Unreal, delivering that for people to get real value from it. But hopefully that will be something that's coming around later next year. Anyone doing native code, we did recently deprecate the KitKat Note 4 support, so that does mean you can rely on OpenGLES 3.1. You can't rely on 3.2 yet for everything, although probably more so than most markets. If you want to shoot for just the latest and greatest headset and the latest OS version, you might not be hurting yourself as much as you would think based on maybe other Android stats or some other thinking. The Oculus Performance tool, I want that to be the first tool that everybody reaches for to grab and take a look at why your performance is not great. It's a little shaky right now, but it's working its way up. I'm hoping that we can dedicate a full-time engineer at some point to just saying this is going to be the tool that we just want everybody using all the time, whereas right now I only grab it when I'm not getting the results I need from a cursory evaluation some other way. I don't reach for it as fast as I wish I did, so I want that to become a better tool. The tool that I've had the kind of love-hate relationship with is Snapdragon Profiler, where when it's working and it's getting better and better, it is really valuable. It can capture, you can do a couple important things with it. You can capture a snapshot of your frame and then go through every draw call, see what the bandwidth was used for all of it, evaluate how much textures you're using, what the shaders are, and it's really useful. And then you can do a real-time trace of how things are going dynamically, or you can do a trace capture, which is like a systrace in that it can capture all the CPU stuff, but critically for graphics programmers, you can also capture the exact things that are happening with the GPU. So you can see the difference between when it's rendering eye buffers, when it's resolving things, when it's doing the time warp. And I need to make another blog post that has some pictures about this where you can see whether it's a healthy designed application and you see just time warp versus an application which is tripping over itself and might have unresolve of a color buffer, render to a separate frame buffer, back and forth here, and having some of these things that are really unnecessary or should be designed around. And it was to the point where it worked on some old Note 4s, and I never got it working right on the S6s. It's right now I have it working on a Note 7 in my office, and while we're supposed to swap out Note 7s, it's like someone's going to have to come in and steal that from me because I don't want it to go away right now. In visual quality, the last blog post that I did write just in Facebook, where apparently somebody is trying to get images for it to put it up and put it officially on the Oculus blog, but I went over all the things about visual quality and aliasing, and this is something that I speak about in practically every single application that I look at. The quality is not what it should be. And again, the reference quality that everybody should look at is the super high quality 360 photos, where ideally all graphics would look that good. It would have that sense of solidity, that it is stuck there. You're looking around and it's not rendering it for you where you see pixels coming and going. And I laid out like the top 4 or 5 things on there that are really important. But anti-aliasing, using a forward render with multi-sample anti-aliasing should be basically a requirement to get in the store. Again, I would have waived that for Minecraft if I could have gotten it out earlier, but every application that I look at other than that that doesn't have it on, I would say you need to turn that on before the store will accept it. We have made our defaults right now have been set up so that we default to 4x MSAA for the Mali and 2x for the Adreno, because it's almost free on Mali and there's a modest performance cost on Adreno. I would actually recommend changing that now. I would recommend always going at 4x, and if you find out that you actually are fragment bound on Adreno, just scale down the view buffer a little bit. Use a 960 instead of 1024 or something, because that's some of the best quality that you'll get for a modest change, and that doesn't take re-architecting anything. It's just, I want this MSAA, and maybe I need to switch down the resolution of the buffer a little bit. The thing that jumped out to me on several apps that I reviewed on Wednesday, there's got to be some Unity sample that people are copying and pasting that's doing the kind of wrong thing here, where there's a clear case of people download images from the net, and they come in probably as a JPEG, and it's not generating bitmaps. So I see this case of, I'm looking at the Fox Sports application, where they had a really good looking scene around it, a lot of things that I thought were very nicely done, but then they had the panels to select it, which were dynamically streamed down, and they were aliasing just horribly, where it looked like they had probably pulled down an image that was at least twice the resolution that was necessary, and it was being crunched down, drawn like that, which is bad for performance. But the worst part is everything is fizzling. Everything is moving where the constant microscopic motions of your head are causing the pixels to come and go and jump around. So everything, this should again be, we need an automated test for this somehow that's capturing things. If you draw an image that's not bitmapped, unless you totally know what you're doing with pre-filtering and sizing of things, you should always have bitmaps, and you should always be in trilinear filtering. That's one of the biggest things that jump out. Some of the subtle things that I point out to people beyond the most blatant obvious things that are hardware restrictions with Gear VR. Most of you have probably seen these. It's worth designing around them. If you have something that goes all the way to a deep black, then you have deep blacks and then like slight gradients up. As you move around, there's this nasty smear effect that happens just based on the way the displays are responding. On PC, they do some neat stuff with overdriving the display and time warp to try to compensate for that. We really can't afford that on Gear VR. It's a lot of extra cost. So avoiding solid black next to other dim colors is useful, but then you also want to avoid full white, especially if it winds up being kind of in the extreme corners of your vision, because the 60 frames per second display on Gear causes more flicker sensitivity, and the bright colors are a bigger issue for that. In UI design, okay, I am running out of time, so I got to get super fast on some of this stuff. So the biggest thing that I want to impress on people is that you should not design VR apps just to be novel. And this is a mistake that practically everyone makes to some degree, of saying, this is virtual reality. I don't want a boring old style interface. I want something that, that uses VR. I want things over here and moving around. And this is just misguided. This is not a matter of saying, well, it hurts your performance or the visual quality isn't as good. It's actually not the right thing to do. In terms of the user interfaces, if you've only got a couple options, then no big deal. Do your big giant floating button. But as soon as you've got enough complexity and that performing the operation is actually a task, like find what you want to look as you browse through a lot of these things, or read this paragraph of information, or read this post that's going on, these are things that actually are best done on 2D surfaces. And more than just 2D surfaces, they're best done on opaque 2D surfaces, where there's a design aesthetic to use lots of transparency and to think that, oh, it's neat that I see through this. And this is one of the things that the movies perpetuate badly, where everybody's vision of the future has the translucent things popping up that you're poking at in space. And you really do not want to have things on translucent surfaces. You do not want to have text floating over empty space. Every once in a while, you'll come across a store in the mall that has text on a window, on a store window. And it's worth looking at how unpleasant that actually is to read relative to something that's printed on an opaque poster board. So you really do not want to do floating text, because it's worse in VR, where in traditional gaming, it's surprising how much you still see this. Traditional game developers are at least aware of it, and you'll think, OK, we'll either do an outline or we'll do a little black smudge behind it. But you still see some problems with it. But not only is it as bad as traditional game design, it's worse because of the actual different depths of vergence that you've got, where your eyes are reading text, but if they can twitch to something that's in the background, your eyes actually are moving back and forth, fighting the lack of focus, the lack of varifocal in VR, and it's really a bad thing. And designers are usually not, working in Photoshop or something. It's like, oh, this looks good. I've got my nice high-res layout, with the fonts setting on there. It looks okay. But in VR, and maybe they glance at it in VR and say, yes, that's my vision. But if you live with that design and you work with it for hours at a time, you're using it every day, you don't want to inflict that on your users. You want opaque backgrounds, legible text. And the biggest thing that I want to push going forward is, I call it the surprising optimality of 2D interfaces for VR. I actually think this is the right direction to go, that we want to be pushing. Design it like a great 2D UI. Designers have so much experience here on making the mobile apps, web apps. We know how to do this. We have tools to let us do this well. Build an awesome UI there, and then use time warp layers to project it onto the screen at this super high quality pixel fidelity, so it looks with the solidity of the backgrounds, the 360 photos. Every pixel counts. You get it at the right scale. It's not this abstract scale of abstract GL coordinates or something. You can say this is going to be 600 pixels by 400 pixels. Time Warp will set it up and position it so that it's exactly right. Every pixel that you make in there makes a difference in VR. It comes out perfectly filtered. You can use the magnifier on your desktop to zoom in and change the pixels, and it makes a difference in VR. We can get quality that is several times more what we've got right now. In the actual games, when you have to present something and you can't use a layer for different reasons, you want to make it big and bold. I try to say, what would Nintendo do? If you look at what a game like a Mario or a Zelda game, and there's a lot of subtle wisdom in things that maybe they've only got 3 things and 20 characters that are put up there that are communicating the important things, but they're big enough to be legible, and that's the way you need to design in VR. I saw dozens of applications in the last couple days that had text that was difficult to read, that was fizzling in and out, and text can add a lot of value. I commented how much more valuable 360 photos was for me when, instead of just swiping through random great-looking photos, they had the little sentence or two that came with someone's Facebook post saying what it is, that grounding that it adds to it. That was real value, but text has to be comfortable to read. Many times in the last couple days, I was presented with text that was literally uncomfortable to read. I had to concentrate and focus instead of just the instant snap, being able to grab something or sight reading through it. You had to stop and read through it because the letters were moving around. It was hard to see. There's immense value to be had there. There's things that with scrolling, when you're presenting a large list of things, I think it's been a tragic UI failure in some of our Oculus's early stuff where we've designed for this safe zone, like it's a TV set, where you can't go near the edges because you might be covered by a bezel. So we have this small set of tiles to select from, and maybe you can swipe and scroll through it. And I think that's bad for several reasons, where ideally, you don't want iconic representations of things. When you're browsing for new content, you want something that sells you on the content. And one of the things that's been interesting is, I think there's a minimum size, sort of a minimum field of view for presenting an object that makes it feel beautiful and enticing. When you shrink things down far enough, you're making an icon that you will sight recognize, and you can choose and jump between icons directly. But if you want to show somebody something, do you want to look at this? Is this enticing? Do you want to buy this application? Do you want to look at this photo or view this movie? There's a minimum size and a minimum quality where you start appreciating the movie artwork or the thumbnail for what it is, rather than sort of a key to what it will become. So I think larger things and letting it go all the way off the screen, letting it kind of cover the entire edges there so you can have bigger things. And when you see something at the edge of the screen and it's cut off, you know that informs you that you can scroll, that there's more there. We've had failures in some of our design where we have a list of options and there's more options there and you can scroll. I did this with 360 photos where I needed to go, where did my photos go? We had added one more option for the Olympics or something, and it was added off the scroll list. Now, we had the little drippy scroll bar thing on the side, but I didn't actually notice and appreciate that that was there because I saw 6 options or whatever there, and I thought, well, where did it go? Is there some other way to get to it? If you've got a scrolling list, ideally, if it goes off the screen and you see part of it, humans instinctively know if something is kind of cut off in your field of view there, all you have to do is look down to see the rest of it. And that's a very valuable thing to be doing in VR. If you have to cut something off inside the visible space, literally cut it off. Make sure that you don't show an integral number of things. Show half of something there, which gives you a little bit of information, and have a demarcation line. Don't just stop in space and expect things to magically fill in. Have something that cuts it off and restricts the view from it. A ton of UI things, like all the things with the gaze cursor, where these are lessons that we're learning over as we're building these things. The early native apps had gaze cursors that would move around, and I did this funny fizzly thing when it was projected behind things because it's really bad to have to have something that's at the wrong depth. That's one of the worst things you can do to users in VR, is have something like your gaze cursor that goes behind a physical object, but it's actually drawn on top of it. That causes your brain to fight with your eyes about what it's seeing. And there can be even worse things with macroscopic geometry, but it happens unfortunately commonly with the gaze cursor. So I've really moved my opinion from, at the start we were thinking we were going to have these crazy VR 3D UIs, interesting things going on, and maybe you're going to be interacting with lots of different things. Now I'm all about this optimal 2D user interfaces, because another side benefit, aside from the goodness of the layer projection, the goodness of all of the tools, it means you know exactly where your cursor is supposed to be. The cursor should be presented as close to possible of exactly on the surface. You don't want it floating ahead of it, because then your eye does this weird little clicking between focusing on this at this distance and then focusing on what's behind it. You want it to be on the surface. And you actually want it to be gone as much as possible. There are so many cases where a gaze cursor is left up and it's doing nothing useful. Like you've got a lovely environment behind you and you're looking around, but you've got the little cursor floating around, really just kind of getting in your way. You have cases where you bring up something to read and the cursor is right in the way as you're trying to read things going across it. The cursor, if it's drawn into the 3D world, is also a frame rate indicator, where that's one of the first things that when I look at a game, I move my head back and forth. If you see a double vision of the cursor, it means it's running at 30 frames per second instead of 60. We can fix that with time warp cursors, where you can put that on top of the layers, and then it will never skip frames there. It'll stay smoothly around. But you want it to go away as soon as you can. Interestingly, you don't want it to snap away just as soon as it's off of a visible or an interactable object, because we had a case with the Oculus Prologue where they had a relatively small thing to click to go to the next area, and they had the gaze cursor go away when it went off of it. And it was surprising how many people would have trouble finding where they were, where you don't have a good sense of exactly where you're looking at without a cursor. If something is less than maybe 20 or 30 degrees of visual arc, it's hard to point on that without the cursor, so you need to make it become visible when it's within, say, 15 degrees of an interactable object. And the best thing that I saw, again, Prologue did a great job of, instead of just fading or blinking the cursor out, they had it shrink away into the distance, which worked out nicely. I thought as you came in, the cursor grew up into being, and then you could place it over an interactable object, and you could do something useful with it. Say 2 minutes and go. So some of the things that like one thing that I saw one of the applications do is we are getting a user interface paradigm that people are expecting. They had double tapping to make something make it perform its action, which is something that just feels weirdly wrong, because we have several hundred applications now that have certain paradigms for working on things. But they were trying to address a real problem that we struggle with, is that when you give it to somebody that doesn't use Gear VR all the time, they're always mashing their hand onto the touchpad, they're settling it on, and it's activating things. But one of the alternate ways that you could solve that is to have a smaller activate button that you have to at least be able to go and tap just to enable the user interface, and then make it real after you've mounted. Similarly, something that I've come around a little bit on is the use of gaze and wait timings, where I railed against that in the past, like kind of the Kinect, the zero-button mouse sort of effect of you hold it there and you wait. In all cases, you should be able to tap to complete those, but I kind of buy into many passive experience cases of people not even wanting to lift up to the touchpad there. You want to be able to just look around, look at something and wait a little while, wait a couple seconds if you're not in a hurry. But in many cases, when you're active, you want to be able to make sure you go tap, tap, tap. You want to be able to accomplish things in hundreds of milliseconds. So you always want to be able to click that clear. The gaze cursor, yeah, distracting from the scene, losing the ability of indicating something to interact with. One case where it turns out you can remove the gaze cursor is if you've got a large field of panels of apps, and one's always selected and you don't have spaces between it, you don't need a cursor because one is always going to be selected. You can always be looking around, you see which one is selected. There's subtleties there about you want a hysteresis between the selection, where you never want to be able to sit on the knife edge of something as it jitters between two selections. You want to give your current selection a broader area until you finally fall out of it. Then it can revert back to selecting the other one. All right, they say I'm totally out of time now, and I'm 3, 4. I had a ton more things to go over. But again, well, anyone that's interested, we can probably adjourn to the hotel lobby or something, or wherever they chase us out. So thank you all. Excellent.